Hey, welcome to the show, guys. We got a great one lined up for you tonight. Hope you and yours are doing well in these challenging and troublous times. If you'd like to support this channel, PayPal and Patreon links in the info box below. Like I said, we got a great show lined up for you today. We're going to go over the Coriolis effect. Many people love that argument. And of course, the Black Swan. But first off, how many ballbusters we got out there today? Ballbusters, assemble! Tap it.
Hello.
Good evening.
Good evening. Of course, you all pile in right at the end, right? So I could get a good sound check on everyone. Thanks.
Shall I let everyone know who's actually here? So we've got Bad Christian, otherwise known as Bible Literalist, or Paula, to be more precise. Hey, Paula.
Hello. How's everybody?
Very well. Good to have you. We've also got Righteous Force, honorary member. How you doing, Righteous?
Hey.
And
Wow. Okay.
Well,
Don't get too excited.
and we've also got 10th Man. How you doing, 10th?
I'm dripping wet. I just got out of my hot tub.
With your cigar.
Yeah, with my cigar.
And last but no means least, Adam Meakin.
Good evening, everyone. Hope you're all okay.
Pretty fine, pretty good.
And
Not coughing.
Hey, Nathan, we got Betty. Is Betty here?
I don't think so. I didn't. Is she here? Oh, is she? Sorry. I can see you there, Betty. Hey, Betty.
Hey, I'm here.
Hey,
A
girl.
little late. Yeah.
And Anthony Riley, otherwise known as Sleeping Warrior.
Woohoo!
Oh yeah, Anthony, the big boss, has been in. Good.
Hey.
Hey, what's happening, Tony? Oh, that's
Hey.
yeah. Thanks for coming in right before the show. I appreciate that.
No worries. What are we talking about today then?
I think you did it purposely. man.
Swan.
I've just finished my tea. My dinner.
All right, yeah, dinner. What you have for dinner, man?
I had what they called filling potatoes with filling and beans and cheese. Yeah, baked potato with cheesy beans and like stuff. It was fit.
I need to ask Anthony to refrain from claiming that the Coriolis effect or any arguments revolving around the Coriolis effect are in any way, shape, or form desirable or pleasurable for me, because they're not. I just want to make that clear right from the outset.
Would
Let's
that be
be
a
clear,
third
everybody-
reference frame?
Everybody
revolving
knows
around
that
it.
Coriolis is Nathan's guilty pleasure.
Not guilty. Somehow pinned on me because I ended up talking about it on Ballbusters, that somehow it's my favourite argument or something. Far from it.
Well, at least Anthony was direct and not roundabout it.
It's an equivalence because he likes arguing for gravity. In fact, if we were arguing about Coriolis, somehow Anthony will weasel gravity into the argument. Somehow, some way.
Just because it's so boring. It's like it can't apply to the Earth unless it's turning, right? You've got to prove that the Earth's turning, otherwise you can't have Coriolis. Come on. End of sentence. That's it. It stops.
It's not. That's just weak. They're going to make an assertion that you prove it with a 15-degree turn of the Earth underneath the gyroscope. That's going to be their assertion. And they're going to say that does prove it. Where are you going to go from there?
Oh my God, did you hear Fight the Flat Earth against Nathan Thompson last night with this point? He claimed that there was a scientific experiment that's been done, right, to do with Sagnat, but his starting point, you know, the first stage of scientific method, they observe phenomena. Do you know what he said? He said, the observed phenomena is that the stars appear to rotate, and that tells us that the Earth must be turning. And I'm like, what are you talking about? We see the stars turning. That doesn't tell us that the Earth's turning. It tells us that the stars appear to be turning. But he totally flipped it around the other way, and I'm like, oh my God, utter moron.
Step one achieved, though. I mean, in terms of observed natural phenomena, I would accept that. That's definitely an observed natural phenomena. But then,
No, you misunderstood. You've misunderstood. It wasn't the observed natural phenomena that he got wrong. It was his interpretation of it. He said that the stars turning tell you that the Earth's turning, and I'm like, what? No, they don't.
That's
They tell you the sky's turning.
That's where he's going wrong. Science isn't about an interpretation; it's about establishment of cause. So if your dependent variable is the observed phenomena of the stars turning, then what are you going to try and establish? Well, you're going to try and establish the cause of stars turning. So you're
know.
going to try and vary and manipulate something you think causes the stars to turn.
I know, but it was his interpretation that was the interesting bit, not the observation itself. It was the conclusion of his observation that he thought was proof that the Earth turns. And I'm like, no, it's not. You'd have to listen to it, Nathan. I'm assuming he didn't listen to it.
Hey, but I do, despite the fact that you think it's my favourite subject, I do just know the argument like the back of my hand, to the point where, you know, the assertion of science is the bit I'm cottoning onto here, not the necessary constituent parts of his Coriolis assertion. It's more the fact that if that's asserted to be some sort of scientific endeavour, then science is very narrow. And DV, yeah, you've got that. Stars turning, yeah, great. That's dependent variable. So what's the cause of stars turning is my next question. And some assertion of Earth turning. Oh, right. So you validated that with science, did you? You started the Earth turning, stopped it turning, varied and manipulated the Earth turn. No, of course not. This won't be science is the only thing I'm picking up on here.
It's non sequitur right from the get-go, right? Because what causes the stars turning? Well, the rotating Earth doesn't cause the stars to turn. Think about that one for a second. That's a non sequitur right there, isn't it?
Yeah, okay. If I insert the word apparent, appear to turn because they claim Earth's turning, but you're still not going to validate that with science.
Yeah, I wasn't dogging you out. I was just if you would have that dependent variable as the stars turning, right? The cause of that wouldn't be the Earth turning, right? You couldn't put that in a hypothesis, even though it's preposterous even to consider it. But even that is non sequitur. Grammatically, it's non sequitur. Follow?
But the apparent effect isn't what stars aren't turning. They may appear to turn, and by their assertion, they appear to turn because Earth's turning, but ultimately they're not turning. So to assert that you're going to try and cause something that's only an apparent effect is to try and assert that you try and cause an apparent deviation in terms of Coriolis. Well, what do you mean cause an apparent nothing's happening?
Right.
It just seems to be happening. How's that going to be a dependent variable? That's what you're saying, right?
Yeah, exactly. Yeah, and it's a non sequitur. In fact, here comes another good one too. Well, let's get back to what he said. Who was this? Nathan Thompson and who? Hello?
Fight the flat Earth.
Oh, jeez. Oh my word. Even if you say that he doesn't know, he's scientific illiterate, right? Because it's not even possible to formulate into a hypothesis like we were just saying. The whole subject is not science at all. So just what he did was bash his own head in with the shovel, unsolicited, essentially. Now, another unique thing, like somebody just brought this point up to me on Discord. I forget whose name it was. I'll give you a shout out later. He asked me a couple questions yesterday, and one of them was what the Coriolis effect. Ironically, what we're doing today, and he says, well, is that science? And I, right off the cuff, I was doing other things. I wasn't concentrating on it. I just thought of cause and effect. So the Coriolis effect, you can cause and affect the Coriolis effect. However, it's not science because there's no viable dependent variable. You guys got that? You guys get that one? Follow?
I was watching Tenth and Adam flashing away.
I've been trying to say something here. I was going to wait till QE was done.
Can I just say QE can't be heard? I'm just seeing in chat you're very low, QE.
Am I very low in chat?
Yeah, that's what Kat just seen.
In the BALLBUSTERS chat or in the audience chat?
In the audience chat, the audience was saying, is QE's volume low?
All right, let's try this.
QE
Radio check,
low.
radio check. How about now? My levels are great.
No, but I find that as well. What seems great at my end is often low on the output. So yeah, if everyone else can
Okay, it's coming in fine. Everybody says sounds good. Better.
Coming in fine now. So did they hear my entire rigmarole over the scientific illiterate, Craig Fat the Fat Girth?
Go ahead and repeat it.
I think there can be no harm in that, can there? There can be no harm in saying that again.
I was trying to do mic discipline. Nathan always says, back away from the mic, back away from the mic. So I'm trying to employ that stuff. Now I'm running into all kind of problems. What's up with that? All right, so let's go back. So he showed initially, as soon as he said that it was scientific evidence that his star's rotating, he showed unequivocally that he's scientific illiterate and would fail 5th grade general science because you can't form a valid hypothesis. Right? You can get the observed phenomenon, yeah, but no hypothesis. Now, I had somebody ask me I think it was last night or yesterday, sometime yesterday, about the Coriolis effect, ironically, what we're going over today. And they said, well, is the Coriolis effect science? And without me thinking I was doing other stuff, and I said, well, it's cause and effect, so I put down yeah, without thinking about it, right? But then he came back and he says, do you have a viable dependent variable? And I said, nope. I had to say it, right? Because I don't. I have a cause and effect relationship for sure, but not a viable dependent variable, i.e., this is not science either. Follow?
Yep.
I suppose you've got to find a circumstance where you've got something naturally deviating from your position. Yeah, this is a bit of a train wreck as a DV, isn't it?
It is. Yeah, you have to find something that's naturally rotating.
I got it.
What?
Every time I get up fast, I see stars in my head spinning
No,
around.
that could have worked, man.
Now, with Adam on the panel, Adam, is that due to blood pressure not being regulated properly or oxygen levels?
It's hypertension.
Postural hypertension.
Hypotension, hypotension.
A rate of delayed reaction to your baroreceptors to tighten up your arteries as you stand to maintain your blood pressure.
What are you, a giraffe?
Well, there's another anti-evolutionist point, isn't it?
Anyway, even if you're on a cyclone, like in a whirlpool, your dependent variable is still dependent on your observation of something happening, though, isn't it? As opposed to you looking upon something occurring in nature, it's dependent on you seeing an apparent deviation. Well, how can you seeing something occurring as opposed to you watching something occurring be the dependent variable? Right,
you're right, exactly. Not only would you have to find something that's rotating in nature, you would have to be on it.
Yeah, you've got to physically be part of the experience of an apparent deviation. In other words, Coriolis effect is described as you witnessing something leaving your continuing to rotate frame of reference.
Yes.
And you watch it seem to deviate, even though it's not. Well, that all involves you watching or witnessing something. Well, it's hard. This is really hard to phrase because watching a phenomenon occur or a phenomenon occur is still you watching something, but it's not you being part of the experience of the dependent variable itself. It's really quite hard to phrase this.
Yeah, it is.
I've got one, Nath. Pirates of the Caribbean, where they're in the whirlpool.
Right.
The two ships. So that would be the only way I can think. You say you've got to be involved in it, haven't you? So if you were on a whirlpool trying to shoot the other ship, then I suppose you're going to have to mitigate for it. So, and you're going to experience it.
That's wonderful, but so far beyond natural, it's untrue.
Yeah, you'd have to.
It's got Johnny Depp in it.
It's got Johnny Depp. That's a great. I love that scene, by the way.
Not the rum.
Yeah, not the rum. Yeah, but that's
you're right. It's hard to get something natural, isn't it?
Yes, that would be the only scenario I could think of, right? That you would be part. It would have to be a whirlpool, and you'd have to be in it. So it's not gonna. It's too difficult, man. But you can't do it.
Hey, John.
Yes.
If you're interested, I've got the little soundbite of Fight the Flat Earth's opening sentence with that scientific method thing with the stars. It's in the first 10 seconds of him talking. It's in the BALLBUSTERS chat if you want to play it and listen to it, and we just have a good giggle at him.
I really, you know what? let's just hold off on that, Anthony. I know you're hard up for that, but I don't want Fight the Fat Girth on Ballbusters. He's too stupid.
He is, but he's fully stupid.
He is. Sorry, man. I'm not going to have him on here now.
No worries.
I thought you said you'd have him on in a Black Swan t-shirt, size small.
Yeah. Oh, speaking of that, I just got, folks, I just got my premium hoodie. My wife just walked in 10 minutes ago with my premium hoodie with the Black Swan and the Black Swan on the back. I'm telling you, it's excellent quality. It looks great. It just went in the washer because some of the way they did the art and the paint is a little stinky. But all you have to do, I just sent it to the washer. It looks great. It feels great. So just want to let you know. Thanks for reminding me about that. Oh, and listen also, before I forget, remember this is a Ballbusters. Now, the audience is begging for a reasoned discussion, not a second grade playground testosterone saturated over talking dumpster fire, where nothing is established or affirmed save for noise and utter chaos. We get that all the time. Everyone entering this Ballbusters Discord voice chat is clean slated. That is, any bad history between guests and any of the panel members will be put aside and not spoken of. However, there are 3 zero tolerance rules. Number 1, no ad homs. That is, attacking the man or woman in lieu of the argument. Number 2, no scattergunning. One topic at a time, each will be exhausted to conclusion before moving to the next, and be prepared to support every claim. And number 3, be polite, speak slowly and coherently. If any of these are violated, you will be server muted and immediately then kicked from the Ballbusters voice chat. Now, if you look in the info box under this video, you will see a link to this Ballbusters VC. You are free to join. After each presentation, there are only going to be 2 today, we're going to allow questions, comments, and rebuttals. Just wanted to remind you and the panel members. Any
The only
questions?
problem with that, though, John,
Again?
it kind of limits the audience massively because there's not many ballers that satisfy them criteria.
Well, they have to be adults, Anthony. This is an adult discussion. We have adults in the audience. People have been listening to this for 5 years, and most can't get very much out of it, especially the new people. They come in here and they say, what in the world is this? Right? Because there's so much history between the regulars on the circuit. And it's not good for communication. No one's message gets through. It's a jumbled muster of a cluster, right? And we don't want that. We want people understanding the topics, not the personalities and the rhetoric, but the actual facts. So that's what I'm trying to do. I may fail, but I will try. Follow?
What's first? Black Swan or Coriolis?
Now, if we do the Black Swan first, we'll never get to the Coriolis, man. Right? Let me tell you something, folks. We're not spinning. Any questions? No. We'll go a little bit further than that. So, how we do this, how we explain this, how I've been explaining this for the past 4 years is using the Coriolis effect. Okay? It's very easy. It's also very easy to get sidetracked. And if you're a veteran and you're trying to sidetrack the Coriolis effect argument, it's very easy to do that because you can bring in all manner of nonsense to derail the discussion. So let's go over it step by step, and hopefully you'll see it. So for the Coriolis effect to exist, you must have, that is, the necessary conditions. Number 1, 2 differing frames of reference. One rotating coordinate system, that's non-inertial, that's the Earth, and one non-rotating coordinate system, inertial, that's the atmosphere and anything in it. Folks, if you are in a position or an argument with somebody about the Coriolis effect, have them cite the definition of the argument, because they're going to come out with all manner of making shit up, telling you what they think the Coriolis effect is. They don't have a clue. I've been out here, like I said, for 4 years, close to it, coming up here in May. And I have yet to have one baller cite the Coriolis effect or the Coriolis force definition. Not one. That's the problem. So let's go through it. Coriolis effect from Sigard Douglas, Introduction to Ocean Sciences, 2nd edition, Critical Concept Reminders. When set in motion, freely moving objects, including air, that's atmosphere, and water masses, clouds, water vapor, move in straight paths while the Earth continues to rotate independently. Because freely moving objects are not carried with the Earth as it rotates, they are subject to an apparent deflection called the Coriolis effect. To an observer rotating with the Earth, freely moving objects that travel in a straight line appear to travel in a curved path on the Earth. Very simple definition. If you take 10 seconds, read it thoroughly again, you will grasp it. I'll guarantee it. It's very easy. We're going to show an example of that here in a couple minutes. So, in other words, anything not tethered to the Earth is freely moving. Number 2, the object in question, not physically attached to the rotating coordinate system, that's the Earth, appears to deflect. That is, moves independently of the rotating coordinate system. Why? Well, because it's not attached to it. And that system's rotating. From a vantage point anywhere on the rotating coordinate system, that is the Earth. So, if the Coriolis effects exist, and this is very important, with respect to the Earth, that's the Coriolis effect with respect to the Earth, then a flight from Charlotte, North Carolina to LA, nonstop, traveling at 500 miles an hour, that's the airspeed, with both of these locations roughly the 35th degree north latitude, that is, they're both allegedly spinning at 860 miles an hour, should be approximately 1.5 hours. However, that flight time is 4.5 hours. The Charlotte to LA flight airspeed's 500 miles an hour. The ground speed is 500 miles an hour. Plus, you have to add the 860 miles an hour alleged rotation speed of the Earth that's rolling into your face because you're traveling west and the Earth is rotating eastwards. So you have to add those two speeds. That equals 1,360 miles an hour. So in my example, two differing frames of reference. Number 1, the Earth, and number 2, the atmosphere, and everything in it. Number 2, the plane in the atmosphere is freely moving. That is, it's not attached to the rotating coordinate system and is flying in a straight path. In other words, based on the law of non-contradiction, each the Coriolis effect with respect to the Earth and the Charlotte flight at 1.5 hours are either both true or both false. The flight is most assuredly false, therefore the Earth is not spinning, ergo the spinning ball goes by way of the dodo bird, or you're a stationary ball geocentrist. That's it. It's that simple. Before we get to my new 5-step plan, any comments? Let's go with some comments here.
I'll start. The Earth is obviously observably flat and stationary. We're not spinning. It's pretty simple.
Okay, I'll throw in a comment. If you're a newbie and you're watching this, the reason Quantum Eraser makes it plain that you've got to get your opponent to restate what the Coriolis effect is because they will flip-flop between there being a Coriolis effect and a justification for there not being a Coriolis effect. So in essence, if you've got a rotating sphere Earth, then you must have Coriolis effect. Now, the priests like Neil deGrasse Tyson, will back that assertion, i.e. the Earth is rotating and we do have Coriolis effect. Check out this footballer. He kicks the ball, the Earth rotates underneath, and then it goes through the goalposts because it left the spinning frame of reference. The non-inertial spinning reference frame of Earth was departed from when the ball was kicked and it left the spinning Earth. So I'll say it again for the newbies. If we've got a spinning Earth, you must have Coriolis effect, like explained by Neil deGrasse Tyson with the football example. Ultimately, there's others like sniper examples, so just stick with one just to keep it shorter. However, if Earth rotates under a football, it must rotate under the plane, as exampled by the Charlotte to LA flight. Instead of about an hour and a half, which is what it would be if you've got 13 mile an hour combined air and ground speed, because Earth's rotating underneath like it did underneath the football, as alleged by Neil deGrasse Tyson. So the flip-flopping element is that the globe heads, our opponents, will then justify why they don't have deviation. And if Earth's rotating, it must deviate. It's as simple as that. They don't get caught up in the weeds of arguing about their justification for it not deviating when it must. That was my only point.
Thank you. Anyone else real quick?
The only thing I'd add is in terms of what Nathan said, if you are taking it to its definition of the fundamentals, is to have to bring out that annoying little diagram, which takes it out of the reference frame, bad choice of words, out of the example of using the Earth to ascertain the fundamentals of the Coriolis effect itself. Is quite useful, I think, before you even get to the Earth, to just define what it is that's occurring. And then obviously when that is applied to the Earth, there's less space to move if it's predefined on a roundabout, or like I say, that annoying little, is it Wikipedia's little GIF?
Yeah. I'm going to pull it up here in a couple minutes, man. It's important, but what I'm trying to stress is make sure you get them to define what the Coriolis effect is, because once they define it, then they can't weasel out and start adding stuff to it. That's why it's important. If you start with an argument or a debate without having either side define it, then you're going to be watching a absolute cluster screw circle a drain at light speed for about the next 15 to 20 minutes. That's what I'm trying to say.
You end up, if it's not defined, that's what I say is getting caught up in the weeds. You start off with an understanding on both sides that the deviation observed from the ground, if you remain on a spinning reference frame, is Coriolis. If you're both in agreement, and it's claimed that Earth's spin gives you this effect, then that's what they're shooting for. But if it's undefined, they're suddenly shooting for explaining away why there isn't one, because it hasn't been clearly defined what it is and what they should have. So my point, just to reassert it, is they should have a Coriolis effect. They claim they have got a Coriolis effect. And if it's defined what Coriolis effect is, it's clear, when they haven't, that they can't start arguing about why they haven't got Coriolis effect. They won't explicitly state, I'm now going to justify why we haven't. They just mix it up in the definition of an argument with Coriolis being the overall title rather than the definition of what it actually is.
The funniest thing is I had a lot of people, and this has been happening recently, stating that the Coriolis effect is conservation of momentum. This is so ridiculous. I guess they're trying to baffle everyone with bullshit, but they just hammered the C4 fire and smashed their own head in with a shovel, because the Coriolis effect isn't the conservation of momentum. The number one reason is that they're two different phrases, number one. And if you have conservation of momentum, then guess what? You ain't gonna have the Coriolis effect. My word, people.
Nuts. So it's like me saying, well, curtains are rugs. Well, hold on. Curtains and rugs are two totally different things. It's like Coriolis effect is conservation of angular momentum. Well, they're completely different things. That's why they've got completely different names. What the hell are you talking about?
That's kind of why I said it's useful to address it with the initial diagram, because what your advanced Baller then reverts to is the differential Coriolis speeds as an explanation for why the phenomena that they don't observe is observed. Does that make sense? Because
Yes.
it's like what QE is saying, get the definition first off. What is Coriolis? It is not a differential of Coriolis speeds based where you are on the roundabout based on you carrying your tangential speed, which is littered with issues in of itself if you want to even allow them that. But that's not Coriolis as defined. That's a differential based on an assumption of, let's say, carrying a tangential speed on takeoff, i.e. going 800 miles in one direction, but actually traveling in the reverse. But this, you know what I mean? To keep things up, it's such a bastardization when they try the apologetics away from the definition of Coriolis. That, like I say, for me, get the definition outside of any earthly viewpoint first.
Yep.
And there's less wiggle room.
Yeah, you just have to have them define it. That's all. And make sure you got the correct definition. Very easy to find it. It's very easy to understand it. So we're gonna roll on.
No,
Betty,
no interruption.
Betty,
interruption.
yeah, I was just gonna say the beautiful Betty Van Velsen. Any admin?
Yeah. Well, there was a lot of admin in the beginning of the show. Did you shout that out yourself, or did you see it?
No, I did not, and I did not see it.
Okay, yeah, you got a lot of stickers by Sam Hine and like saying, "Hey, come on, get on with the show," right? And now you got the last one that says, "Admin interruption for Betty."
Yeah,
So,
thanks.
Yeah.
Thanks for the admin interruption, Sam. You rock, brother. Thank you. All right, is that it?
Isn't that enough?
Yeah, that's enough.
Hello.
Oh, Chocolate,
Good.
what's up, man? We'll stop the show for you. How's it going, sir? What's good?
Not much, not much. I'm good. Going on? What are we talking about?
Thanks for the excitement.
What's going on?
Yeah. What's going
My
on?
God,
What?
have you been under a rock?
Going on, guys?
We're on Coriolis, Chocolate.
What Coriolis?
Exactly.
Bring it back on track before QE launches back into the presentation. So we're at the point where we're saying the advisable thing to do, Chocolate, at the beginning of any debate about Coriolis is get your opponent to establish exactly what it is by defining it. So have them repeat back to you what Coriolis is, so everyone's on the same page of what the claimed proof of Earth spin actually entails.
Right.
Not,
Yeah, I agree with that exactly.
Not only
Then
have
when I
them
can't-
hold on a second. Not only have them define it, they need to cite it. I don't want to hear what they think the Coriolis effect is. I want to know. We have to establish what the Coriolis effect actually is. Follow?
Oh
I
yeah.
got some more admin.
Every time you talk to me, somebody
I
will
know. I'm
talk.
getting ready to go. That's okay. Go ahead.
Yeah, no way, because that will take a long time. You got one from Rakia Live. He said, "Swan flu fund, save the ballers. This bendy crane disease has to be cured. This social distancing is cutting into my nesting. I'm on mute."
Getting into his nesting time, Rocky. You rock, man. I still don't like you. Anything else?
No, that's it.
All right, let's rock, man. I mean, we're gonna be here all day anyway. I'll just take my time. No worries. All right, my new 5-step plan, better known as the 5-point palm globetard exploding fairy tale religion technique. And remember this: if there's no spin, flat Earth wins. We win anyway, but it sounded catchy. All right, see if you can follow this. See, Adam? Your wish is my command.
Oh, you're a gent. I've just made me giggle that. If there's no spin.
If there's no spin, flat Earth wins, and the Black Swan. Black Swan. Now, people, when you look up the Coriolis effect, you're going to get a GIF. Now, we're going to go from their alma mater wiki because they got the Coriolis effect right. It is very simple. In the inertial frame of reference, the upper part of the picture, the black ball moves in a straight line. Do you see the black ball moving in a straight line, everyone? See, this is straight. Okay? However, the observer, the red dot, who is standing in the rotating non-inertial frame of reference, the lower part of the picture, you see this red dot right here? And see this red dot right here? Well, when this red dot starts to rotate this way, starts to curve, and the ball's going straight, what's happening here is the ball's going straight, but since the observer is rotating and curving, it appears that the ball is. But it's not. It's going straight. Like I said, however, the observer red dot, who is standing in the rotating non-inertial frame of reference, sees the object as following a curved path due to the Coriolis effect. Now, did anyone hear me say anything about latitude or longitude lines? No? How about directions? Was directions mentioned down here? No? Why is that? Well, it's for the same reason they don't mention gummy bears and chicken soup here, because it has nothing to do with the Coriolis effect. That's why. No directions. It doesn't mention any speeds here. It only shows this rotating, right? It shows two reference frames. One that the ball is in and one that the rotating reference frame observer is in. This is very simple to understand. If the Coriolis effect exists on the Earth, A, the Earth must be spinning, that is rotating, that's the non-inertial reference frame. B, the object affected by the Coriolis must be moving through the non-rotating inertial frame of reference, untethered to the rotating non-inertial frame, such as airplanes, helicopters, balloons, missiles, bullets, etc. Point number 2. The Coriolis effect, and this is from thoughtco.com, the Coriolis effect, also called the Coriolis force, is defined as the apparent deflection of objects such as what? Airplanes. Moving in a straight path relative to the Earth's surface. So if somebody tells you that the airplanes are not subject to such effects, they're full of it, because airplanes are not tethered to the Earth, making them subject to the Coriolis effect if the Earth was spinning. Very simple. Point number 3. This is the tricky one. So at this point, as long as it's established, and it is, that airplanes are subject to the Coriolis effect, we now drop the Coriolis effect argument. Let me say that again, because this is a tricky part. We now drop the Coriolis effect argument. The actual argument is the Coriolis causes. That is, the conditions that afford the existence of the Coriolis effect. You must have two differing frames of reference, like I just defined above with Seagar Douglas, and I just showed you from the Alma Mater Wiki. So, point number 4. The velocity of a plane, that is the airspeed traveling due east or due west, must be either added or subtracted to the velocity of the rotating Earth, depending upon the direction of travel of the plane. Make sense? So if a plane is traveling due west, at 500 miles an hour airspeed and the Earth is traveling due east at 860 miles an hour ground speed, the velocities are added together. 500 miles an hour air, 860 miles an hour ground equals 1,360 mile an hour total. I hope everyone follows that. It's very easy. If a plane is traveling west and the thing that's underneath you is coming at you east, then you have to add those two velocities together. This is second grade mathematics. So a plane traveling due west with an airspeed of 500 miles an hour has a total ground velocity of 1,360 miles an hour. That's 0.4. 0.5. To find the time the plane flight would take, we use the formula distance equals rate times time. Then we rearrange that formula to solve for t, time. That would be distance over rate equals time. So let's do it. So the distance from Charlotte, North Carolina to LAX is 2,115 miles. The rate from above is 1,360 miles an hour. So we take 2,115 divided by 1,360 miles an hour. Ergo, the flight time must be 1.4 hours. That's it. Does this flight time exist? No. Therefore, the Earth is not spinning. Ergo, the spinning ball goes by way of the dodo bird, or you're a stationary ball geocentrist. Simple, voila. Now, spinning space monkeys. Take 5 steps. Now, the only way the above can be refuted is if you're of the position that the atmosphere spins with the Earth. And I yearn, I pine for people saying this. I just sit back and wait. Right? So then, Einstein, please explain how the Coriolis effect can exist when the necessary conditions for it to exist are two different coordinate systems, that is, reference frames. One rotating, non-inertial, that's the Earth, and one non-rotating inertial, that's the atmosphere and everything in it. I'd pull up the GIF again, but I don't want to insult your intelligence. So, if you can't do that, this is a violation of the law of non-contradiction. Because if you don't have two differing reference frames, you don't have the Coriolis effect. Simple. Number 2, show the experiment where gases or a gas rotate in lockstep with a rotating solid body just 5 centimeters above the surface, then provide the mechanism. You do understand gases have no intermolecular bonds. Obviously rhetorical. So do gas molecules attach to the Earth and each other by Velcro, superglue, molasses, pixie dust, other? And gas molecules, that is air, vibrate and move freely and randomly at high speeds. Let's take a look at this. Okay. From Purdue University, because it's a good visual for retards. Not present company excluded and flat earthers in the audience, right? You see what's going on here, people? And it's not going on. Why'd you stop? What's up with you? Somebody's... Let's try that one more time. Somebody's sabotaging me. I gotcha. You didn't think I'd do it a second time, did you? All right, you see, this is the microscopic view of solids, right? They're moving, but it's pretty tight. Then liquids, they're moving too, but they're constrained. As opposed to what? Gases. Lucy has some explaining to do. How can they be attached to the Earth and also moving randomly and freely in all kind of different directions, right? It's a violation of the law of non-contradiction again, folks. Like I just said here. How can gas molecules that make up the atmosphere that move freely and randomly at high speed, yet, according to the Baltards, rotate in unison, that is not moving freely and randomly at high speeds, with the Earth from west to east? Yep. You got it. It's a violation of the law of non-contradiction number 2. Let's go to number 3, my favorite. Please explain east, north, and south surface winds on a spinning ball that has the atmosphere that is air, wind, and gas rotating with it from west to east. Because if that was true, if it was rotating from west to east, then all the winds would spin in one direction. All the winds. I put surface winds on here because it's easiest for us because we're standing on the surface. We know there's different types of surface winds. Right? Violation of the law of non-contradiction number 3. Also, if you watch the Weather Channel, you can see storms that are moving west. How you explain that? East to west. How can they be moving from east to west and then west to east at the same time? Please. Bonus question, how can you have different wind speeds moving in different directions simultaneously at differing elevations of the atmosphere, all the while the atmosphere is collectively spinning east in unison the same? It'd be easier reconciling married bachelors. This is violation of the law of non-contradiction number 4. By the way, these are contradictory statements. The atmosphere spins with the earth and the existence of east, north, and south surface winds. Not even speaking to the differing wind directions and speeds we just went over above. Which one of these statements do you think is false? Because one of them have to be false, right? Which one? I know my pick. And incoherent second graders everywhere know their pick. Ballers have a challenging time with it. Moreover, following the baller's yarn, every cubic nanometer of atmosphere traveling horizontally from the equator to the center of rotation must have differing tangential speeds. And every cubic nanometer of atmosphere rising in elevation from each respective horizontal cubic nanometer of atmosphere must have differing tangential speeds. In fact, the higher the elevation, the faster they'll need to travel to keep up. And all of this is rolling along at different speeds in unison? East! Violation of the law of non-contradiction number 5. This is so far beyond preposterous ludicrousness, absurdity, evolution, whatever that is, multiverses, and married bachelors are blushing. And does anyone know how far up this increasing speed rope-a-dope fairy tale spinning atmosphere ends? I'd like to see that. It'll give a whole new meaning to guillotine wind shear. Goodness gracious, people. P.S. Are the gas molecules attached to each other by Velcro, glue, pixie dust, molasses, other? And where is the energy coming from for the continuous shot in the arm injections needed to keep each successive cubic nanometer atmosphere higher elevation brethren in tow? Let me stop right there before I get to hurricanes. Questions, comments?
Go first. Any objections?
By all means, sir.
No, great. Said a couple of times, and it's got me thinking about, really getting somebody to understand how the example works, and he highlighted that twice. But then he didn't actually verbalize it. But I'm gonna do it in such a way. This is new. I'm making this up as I go along, but I'm hoping it will go well. So, if you're in the audience, follow along with me as I describe this to you. So first and foremost, imagine a roundabout or a merry-go-round. So you've got a merry-go-round in your mind. Now have that merry-go-round be the size that could fit in the room you're in now. So it's in your enclosed room, wherever you are. Now you're going to be sat on that roundabout, and you're going to spin that roundabout round, and you're sat on it. Now, on the roundabout with you is going to be a TV set in front of you that you can look at, and you're going to be holding onto a fairly sizable ball, like a beach ball or something similar. So as you're spinning around and around, holding your beach ball and looking at your TV, as you look at the TV, it's not moving. And as you look at the ball you're holding, it's not moving. Everything's effectively not moving from your frame of reference. Even though you're on a roundabout and it's spinning around, it's the ball and the TV aren't moving. Now that ball, coincidentally, is completely ram-packed full of helium. And what you're going to do at some point is let go, and it's going to fly upwards to your ceiling. Now, from your position, the TV is still as far as you're concerned, not moving. But the ball has hit the ceiling and then stopped. It's just static. It's hit the ceiling. It's stuck where it is because it's full of helium. Now, when you look up, even though that ball is stuck to the ceiling, isn't moving, looks like it's going away from you and coming towards you, going away from you, coming towards you. Now, you look at your TV set, which is on the roundabout with you, and it's not moving. But when you look at the ball, which is also not moving, it's coming towards you, going away, coming towards you, going away. Well, in reality, the TV is moving along with you on the roundabout, even though it looks like it's stationary. In reality, the TV and you are spinning. The ball is actually stationary after you let it go, but from your frame of reference on the roundabout, with it stuck to the ceiling, the ball that is, it looks like it's coming towards you and going away. Now that's Coriolis deviation, an apparent deviation. The ball on the ceiling looks like it's coming towards you and looks like it's going away from you. But in reality, it's not moving anywhere. It's completely stationary. But the effect, because you're spinning, is that it looks like it's coming away and going towards you. Now, we're going to take away all of the walls, and we're going to take away the roundabout itself. And now imagine that instead of a roundabout, the Earth itself is spinning. And instead of a helium balloon that you're holding, it's a hot air balloon. Well, you should continue to rotate underneath in the same way as you rotated underneath the helium balloon when it hit your ceiling. The hot air balloon on a spinning Earth should do the exact same thing. It leaves the spinning frame of reference, which is claimed to be a spinning Earth, and rises up. And what should happen, the Coriolis causes, as qualified in the 5-point exploding globetard effect, is the causes of the Coriolis deviation are the Earth rotating underneath the hot air balloon. Therefore, the hot air balloon would not actually drift away from you. It's just going straight up. You would start to drift away from it. And continents would start to drift towards a hovering hot air balloon, or a drone, or an aeroplane, or anything that leaves a claim to be spinning reference frame. So in the same way, anything that, like the helium balloon, leaves your roundabout, if it's in your room and hits the ceiling and you see it, you drifting away from it, well, the same principle would happen on Earth. Something leaves the spinning reference frame, the non-inertial spinning reference frame, and the ground continues to move away from it. Therefore, if you're in a plane and you're traveling west, the ground's coming towards you as you're going towards it. Conversely, if you're going east, you're fighting against it. So, necessitated the Coriolis causes as described by Quantum Eraser. In other words, don't get into arguing about what Coriolis is, because that's not our argument. The Coriolis effect's very easy to define. Get your opponent to define it, then forget about it. It's defined. We know what it is. We know what it does. Things drift away because things are spinning underneath other things. Simple as that. Once that's defined, forget about Coriolis. Don't argue about what Coriolis is anymore. But to have Coriolis, the cause would be two reference frames. One being Earth spinning underneath the other, which is the air and everything in it. Oversimplified version of what basically Quantum Eraser's done a much more detailed explanation for in his presentation. Hope that helps anybody out there.
Thank you, sir. Anyone else? Paula.
Hey, I'm actually here this time.
Yeah, I caught you out there. Yeah. Yeah. Well, let's try to make it quick. Keep your comments concise and quick. We're not finished with the Coriolis effect, but go on.
Yeah, just I don't know if I missed something. I went out to get a drink, but the issue of an inertial reference frames, people don't understand what that is. A lot of times I hear terms thrown around, but a non-inertial reference frame simply means that things appear to violate the laws of motion because there's two reference frames. And so when people use those terms, it's another thing. You know, I know we don't want to get bogged down in arguing about Coriolis, but the fact is that people keep bringing it up and they use these terms and they don't really know what it means. You know, what's inertial, what's non-inertial. and begging the question overall, that because if we're turning is a hypothetical, and we shouldn't deal in hypotheticals. We should say, okay, I'm standing outside watching the wind, feeling the wind going in different directions, watching the clouds, convince me that I'm spinning, and just start there, because otherwise we're in their sandbox when we deal with hypotheticals. That's about the only thing I can think of to add.
Appreciate it. I know Anthony just absolutely loves this argument, so let's see if he's got anything to say. Buddy, Anthony, Tony. Yeah, that's what I thought. Oh, I got an echo. That means he's coming off mute.
Oh, that was me coming off mute, John. Sorry.
Hold up, Adam.
I'm surprised he's missed his boat though, because that was his chance to weasel gravity in. But oh well. I've just got a couple of points really. First is, if you allow the supposition that the atmosphere is in lockstep, I love the other one, that the other little diagram that gave you the problem, John, because that shows it. You can almost at ground level start to think with the earth spinning underneath, how it could be acting like a fan, a whipping bat, a spinning top kind of effect to generate the speed, so that the literally the level of air that's at that speed is equivalent. But because if you look at that diagram, how it shows how gas behavior and intermolecular spacing is so vast compared to liquids and solids, it's impossibility to then be able to allow a transfer of those speeds up any kind of height, because what passes that speed that you've already given the apologetics for to allow the first ground-based molecule to have full transfer and keep going? What allows that transfer of speeds all the way up through the different atmospheres? And we've said the higher you go, technically, then the transfer has to then defy the laws of physics, because you're asking a molecule going at one speed to speed up the molecule above it in a slightly larger orbit around this ball, to have to go faster than the molecule below it. So it's a total violation of their own physics.
First law.
Yeah. Okay. The last bit, Nath, was to actually ask you, because this whole thing for me, I think Paula alluded to it, is the flim-flam that they'll use around the inertial and non-inertial reference frame terms. And I've got to put my own hand up. It did my head in a long time. I always thought the inertial reference frame is the one that is like, I think of it as the bullet. So it's the one you've given inertia, which was fine until you gave that analogy of the static balloon on the ceiling. But to me, when you're arguing with a baller, that's one thing they keep trying to chop and change and using those phrases to confuse. I just
Right.
kind of wanted you, Nath, because you are the master of unpicking that. If
in language terms, no, you'd be better off with Paula, but that does blow my mind. You're right. So in my example with the balloon on the ceiling or the ball on the ceiling, you on the roundabout are on the non-inertial reference frame, which is, I won't bother detailing why, but that's why I had the TV in the example. But nevertheless, the ball, weirdly, is in the inertial reference frame.
Yeah, it's because the word inertia has to do with the laws of motion. That's all it's about. It doesn't mean that something is moving necessarily, that, which one was caused to move, because both are moving. You're moving in one frame and the bullet is, or whatever, is moving in another. So they're both inertial in that regard in the intuitive sense. But when they talk about that in physics, what they mean is, does it appear to adhere to or violate the normal laws of motion? So if you're on the roundabout throwing the ball, That's the non-inertial reference frame because it appears that the ball is doing something impossible. Does that make sense?
That's a
Yeah, I like that.
a way of describing it that encompasses all the descriptions, probably. Yeah, much better. So I said, I was all good till Nathan's description.
I just have it. That's just my way of reconciling
Yeah.
it. So non-inertial with the TV in the description. The TV, from your point of view, as you look at the TV, is not moving. Whereas from your position, the ball is moving. So that's why that's got the attribution of being the inertial reference frame.
Well,
Because
actually, sorry to interrupt, but actually it's because the ball is moving sideways. When you throw it out away from you and it seems to curve, or it curves to you receiving the ball, you should have caught it, but it went sideways. That's why it's non-inertial. Because it didn't go in a straight line. Yeah.
It's
I
non-inertial movement.
With you, I agree with you, until Adam pointed out that in my example, the ball is still deviating. It's still got that motion from your vantage, but it's stopped completely. It literally has no inertia at all. It's stopped.
Yeah, so its movement's non-inertial.
Yeah, it's confusing because of we thinking of motion in the intuitive sense, like I said, but what they mean by non-inertial is it did something impossible according to the laws of motion from what it appears because we're spinning. That's why it's non-inertial.
But can I ask though, wouldn't the balloon or the ball, as Nathan put it, with the helium on the ceiling, wouldn't that be analogous to, let's say, a drone that's just hovering, that's not moving at all, and you're moving underneath it on the merry-go-round, on the non-inertial reference frame?
Yeah.
It would be the same thing because it's not moving.
Yeah.
But it'd look like it's moving. It'd have non-inertial movement.
Yeah, of course.
That's brilliant, that, Paula. Thanks for that. That's really.
I did like you throwing the TV on there, Nathan. That was pretty cool because it helped to distinguish for people that might not understand this, because I know that non-inertial and inertial reference frames, because I had to think about it a little bit when I first got into this too. So I get why people might get confused, but we've done this so many times that it's like it's whatever now. But yeah, that the throwing the TV in there as to show how it's not moving in your reference frame, but the ball is, as in like it left the reference frame. How yeah, that was pretty good.
Yeah, I'm getting Miley Cyrus visions off it.
I almost want to shout him out, man, but I'm not going to.
Just before that goes into total train wreck. No, it doesn't matter what they're called. So this confusing terminology aside, reference frame 1 and reference frame 2. One is spinning, one is not spinning. It doesn't matter about the confusing terminology. You've got a spinning and a not spinning reference frame. That's all that's important. And when one leaves the spinning reference frame, if you are watching it and remain on the spinning reference frame, it seems to deviate. Even though if it's being thrown, let's forget about my static ball on a ceiling example, if it's being thrown, it's going in a straight line, but seems to go in a curved line. Not because it is curving, but because you remain on a spinning reference frame underneath it when it leaves it. The point being that anything that's left your hand on a spinning roundabout, once it leaves your hand, it essentially travels in a straight path, but from your vantage point appears to curve because you continue to spin underneath. But the non-inertial and inertial reference frame descriptions don't even have to come into it, and didn't in that little amble that I just gave you. You've got reference frame 1, that's the spinning reference frame 2, that's the not spinning frame, and you're sat on the spinning one when something leaves it. That's simple. It doesn't really matter what they're called.
10th.
Really now, after that detailed back and forth?
I was surprised you were even there.
I could have gotten the back 40 by that time. Let's see. I would say the cause, when you brought up the cause of Coriolis, that's what, when I first heard that back in the day, that was the eye-opening thing. What causes the Coriolis effect, the apparent deflection? And once someone understands that, they're going to understand the argument. But everybody who just said everything is very detailed, very true. And I love this argument, Coriolis, because the Earth must be spinning for it to work. But there is no Earth-based Coriolis, so the Earth is not spinning. I love it.
Yep, I agree, 10th. Yeah, and you're kind of put behind the 8 ball being last when everyone gives their spiel, because they'll say everything and you're like, yeah, I agree with, yeah, I don't have anything to say, or I'm not there. Let's try another one. Thanks, 10th. Paul.
You're welcome.
Paul, hello out there.
Hello, I'm driving and I won't say much, but all I hear now is the Glovers are trying to change the argument. It's centrifugal force. If you go east to west, then things are lighter and heavier going east to west. That's the only thing I got to say. That's the new argument.
Oh, that's stupid. We already dealt with that. That Atheism effect. Betty herself clobbered this argument about 2 years ago into the incoherent oblivion and made Geostrieber look like the moron that he is. Yeah, so thanks. Betty, before we start over again, any admin?
Yeah. Go from Steve and it says goal.
Score!
So I think it was a score, yeah. Yeah.
Thanks, Steve. Any thoughts on the Coriolis effect? You've been around this argument for a while, Betty. Also, you probably don't have anything because it.
No, I can maybe do it in Dutch.
Go ahead.
Go ahead.
Oh, no. That's not going to stand. You've got to regale us with the cross effect argument. That was epic. That's a real cornerstone moment for me. I was sitting there thinking this will get a bit of a build up and Betty will get to shine and tell us about this was an epic moment. You've got to tell us more than that.
Do it in Dutch.
Doe het in Dutch. Het is gewoon heel simpel. Je stapt op een merry-go-round en op een draaimolen. En je hebt een drone en die gaat omhoog. En
Okay,
dan
thanks. That'll be about enough.
Okay.
No.
In Dutch. That's just mean.
Yeah. In fact, I might run that. I have that premiered in the next couple of weeks. We could talk about that. But all right, so we want to move. We're going to move to hurricanes because this is hilarious. All right, let's do that. Let's move it on out. Oh, before this, remember the link for the VC, the BALLBUSTERS VC, is in the info box below. There's about 8 minutes left till we get to you guys. So 8 minutes, and then we'll go to any comments, questions, or rebuttals. Okay? So pile on in there, ballers, to defend your heliocentric spinning ball space monkey religion. Now, this is pretty funny, and this goes back to my point about having people define the Coriolis effect. Hey, it's really funny if you have them define, then cite the Coriolis effect, then bring up hurricanes. Get ready to laugh yourself into some tear-jerking belly laughing syndrome you may not recover from. I'm going to show you. So, hurricanes. So you're saying that hurricanes spin in opposing directions in northern versus southern hemispheres, respectively, due to Coriolis? I'd sure like some of the angel dust lace shrooms the distinguished space monkeys are starting. Let's focus on apparent deflection, not real, appears, does not actually in the following citations. We'll go through them real quick. Remember Douglas Seagar above. Remember, because freely moving objects are not carried with the Earth as it rotates, they are subject to an apparent deflection. Apparent. Not real. Not actually. Called the Coriolis effect. To an observer rotating on the Earth, freely moving objects that travel in a straight line appear to travel in a curved path on the Earth. Appear, not actually. From Oregon State and the University of Florida, they adopted the same definitions. The effect of the Coriolis force is an apparent deflection, i.e. not actually, of the path of an object that moves within a rotating coordinate system, like we've been saying 1,000 times above, the object does not actually deviate from its path. I say again, the object that you're observing in the inertial frame of reference, with you being in the non-inertial frame of rotating reference, does not actually deviate from its path. It only appears to do so because of the motion of the coordinate system. Like we showed you in the GIF from Wiki. They're all lining up. Okay? From Utah State University, the Coriolis force is an imaginary force because objects affected by it are really following a straight path. It is an apparent deflection, i.e. not actually, we see from the vantage point frame of reference of the rotating Earth, like we've been saying for the past 25 minutes. California State University, the Coriolis effect describes the apparent deflection, that means not actually, of an object traveling in a straight line. See them all lining up? Let's finish it up with, who do we got here? Encyclopedia.com. See if they have a different definition. Within its rotating coordinate system, the object acted on by the Coriolis effect appears to deflect, that means not actually, off its path of motion. This deflection is not real. It only appears to happen because the coordinate system that establishes a frame of reference, the Earth, for the observer is also rotating, right? You see all them? Here comes the punchline. Now, we've all seen these, right? Whether it be on the nightly news, weather channels, right? We've seen these before. We're observing these hurricanes, according to them, from the inertial frame of reference. They are actually rotating. Actually. Really. They're not deflecting. Deflecting isn't part of this at all. That's the first belly laugher. Right? Actually rotating. What does an actual spin have to do with the Coriolis effect, which is an apparent deflection? Not real, appears, does not actually. Por favor. Let me say that again. What does an actual spin have to do with the Coriolis effect, which is an apparent deflection? What does it have? This is non sequitur. Answer key. Absolutely nothing. In other words, how can clouds be apparently deflecting actually? Answer me that. I want to hear this. If anyone joins, I'm going to ask you this question. How can clouds be apparently deflecting actually? Huh? Violation of the law of non-contradiction on nuclear steroids. This is tantamount to giving a presentation on quantum numbers with excruciating details on SPD and F orbitals. They're not orbitals, by the way. Then concluding that they are responsible for the creation of facultative anaerobe woodpeckers. Alice in Wonderland is more tenable than the ball-tard spinning space monkey religion. The prosecution rests simple. You live in a fairy tale, the end. P.S. Foucault pendulum from plusmass.org. Once you set one in motion, its direction of swing will rotate at a rate of about 0.2 degrees every minute. But in fact, it isn't really the pendulum that's rotating. The pendulum is swinging back and forth in exactly the same direction. It is the Earth which is rotating underneath the pendulum, which makes it appear that the pendulum is in fact changing direction. What does this sound like? It wouldn't sound like what we've been talking about for the past 25 minutes now, would it? If that's true, then why couldn't we just hover in a helicopter in North Carolina for 3 hours and catch a Dodger game? It has to follow, it logically follows from this, right? It's the same thing. I used North Carolina and Dodgers Los Angeles for a reason. Why? Well, because then a flight from Charlotte, North Carolina to LA, nonstop, traveling at 500 miles an hour airspeed, with both locations roughly 35th degree north latitude, both allegedly spinning at 860 miles an hour, should be 1.5 hours, but it's 4.5 hours. Charlotte to LA flight, airspeeds 500 miles an hour, ground speeds 500 mile an hour plus 860 miles an hour, like we went over above, alleged rotation speed in your face, so that equals 1,360 miles an hour. Distance between Charlotte, North Carolina and Los Angeles is 2115 miles. Flight time must be 1.5 hours. Actual flight time, 4.5 hours. It's over. Does this flight time actually happen? No. Then say bye-bye now to your dignified and knighted ball-tard spinning space monkey religion. Oh, by the way, Modus tollens? Let me show you something. If P, then Q, not Q, therefore not P. If the Earth is spinning at 1,037 miles an hour at the equator, P, then a non-stop commercial flight from Charlotte, North Carolina to LAX, traveling at 500 miles an hour airspeed, should take no more than 1.5 hours, Q. The non-stop flight takes 4.5 hours, i.e. not Q, therefore not P. The Earth is not spinning. Questions, comments?
I think it was Kosho that was in an argument. It wasn't on my show, but on someone else's show about Coriolis deviation when it came to cyclonic wind activity. And the end assertion that he had to use to square the circle was to say that the wind was actually traveling in a straight line.
Yep. And it only appeared that they were actually rotating because of the Earth spin. I mean, I don't know how more ridiculous you can get. It's one of my questions that I've asked before. I mean, something that would be taking a picture or let's say quote unquote a high altitude satellite picture of a hurricane that's actually rotating, right? That would be in the inertial reference frame, right?
Yeah.
Anybody?
Yes. The satellite that's taking it. Yes.
Right.
Yes.
Yeah, that would be in the inertial reference frame. So then why would it appear to be rotating? Because shouldn't that deviation just be apparent from the non-inertial reference frame?
Whoa! You're not talking about it. You're not talking about a deviation. You're outside the subject area because the Coriolis effect is an apparent deflection.
You're wrong. No, it's not. It's not. You missed what I said.
Go ahead.
No, right. According to Kosho, when pinned with this argument, his squaring of that circle, which is to say, no, it's not an actual deviation when we're talking Coriolis. It's an apparent deviation. The thing's going straight. So to square that circle, Kosho asserted that the wind was going straight and only appeared cyclonic because we're rotating underneath it. So in other words, in this example, I didn't think the penny had dropped when I said it and there was a long silence. Yeah. That circle, the assertion was made that we're actually traveling in a straight line.
Yep.
I'm sorry. That is too stupid. That's so far off the reservation. It's too stupid to comment. No wonder I didn't understand it. That's moron.
You need a set of ruby red slippers.
Yeah.
To contact that. It is that ridiculous, isn't it? If you're in Kansas and you see a hurricane caused by Coriolis, then there isn't actually a hurricane there.
I was going to scale it down, Adam. You got there before me. I was going to do just that. I was going to say, when you talk about like twisters, Well, you're not talking about a mass scale hurricane that you could look above and only see one small section of it. You can see it over there twisting. You know what I mean? No, that's not twisting. That's a straight line. That is right there. It just looks like it from here.
Only if it's caused by Coriolis. If it's not a Coriolis cause one, it could be
Whoa.
fine.
That's not the Coriolis cause. It's called the Coriolis effect.
Exactly.
Gotcha.
The point, isn't it? So that's the
yes,
next
it
thing.
is.
How the hell did it cause it? But
yes, sir. All right. I don't think we need to go through hurricanes because it's pretty funny, right? It has nothing to. What I'm trying to say is the Coriolis effect, and in relation in context of hurricanes, is non sequitur, because the Coriolis effect deals with apparent deflections. Hurricanes actually rotate, so it's not. That's what I was saying. It's non sequitur. So I don't think we need to go on with this. Everyone gets this. Incoherent second graders and such. Maybe we ought to shift to question and answers and get some people in here. Any objection to that?
I think that's a good move at this point.
We still have the Black Swan to go over. Now, I don't mind. I could spend 5 hours in here. I don't really care. But let's go ahead and move on. Righteous, sir.
John, I've got one thing that needed checking, which was to Elka Administrator Betty.
Oh, God.
What?
She's got a problem with my North Netherland accent, you see.
Yeah. There was some fun going on that I was talked in Dutch, and someone said that I was talking double Dutch.
Double Dutch.
And then she was claiming, John, in the week when we were chatting, she was trying to make out that when I was being kind enough to try and operate her OBS in Dutch, that my accent was not understandable.
Yes, he did.
I mean, you were there, you heard it.
Yeah, I did. I heard
it,
mate. Yep. Yes, sir.
So, I'm not having it, Van Velsen.
Talking double Dutch.
In fact, it was a lot of laughing on her part, by the way.
It's so funny. If you guys try to talk Dutch, it sort of goes past me. I don't expect it. That's for one, and you have such a way of mispronouncing these words.
Yeah,
right?
and your laughing motivates us to speak it more.
Yeah, I hope so.
Hey, let's move on to question and answers, if you guys don't mind. Righteous, sir.
All right, something came up. Betty's got to take over for a bit because I got a phone call.
Okay.
Yeah.
Betty, ma'am.
Yeah.
Let's see. Can we go down?
I'm up for the task. Yeah.
Say again?
I'm up for the task. What do you want me to do?
Can you just go down from the top of the BALLBUSTERS voice chat? Go ahead and unmute and.
Well, the first one is on deaf mute, so that would not be.
Yeah,
possible.
I seen that. I seen that. Okay. I think the next one is coronavirus is
tasty.
Tasty. Okay,
Yeah.
just get your. I'll tell you what. Just have your trigger finger on the deaf mute.
Oh, well, okay. I'm unmuting you, Mr. Coronavirus. You're in the room. Hold your distance.
Any questions or comments or rebuttals, sir, with the Coriolis effect argument?
I think he's holding his distance.
And when you wake up, you will think you are a swan.
Giving me swan bumps already. Okay. Albacore tuna.
Oh my god, yeah. Albariqua. That's correct?
Albariqua, you are off mute, sir. Thank you very much. John.
Okay.
Cool name, dude.
Yeah. You're off mute.
Thank you very much. Matthias.
No. I think he was.
Wait,
I think he was
I
trying.
could see him flashing, but I didn't hear anything.
Hey, John.
maybe-
Okay, John, drop out and drop back in again, and we'll get back to you. There you go. Matthias, comments, question, rebuttal.
Well, to me, the Earth not spinning is kind of common sense because, well, we don't feel any spinning, we don't feel any movement, so there you go.
Thank you, sir. Moose Tone. You are on the air, sir. Questions, comments, rebuttals.
Is it mouse tone, right?
Moose Tone, can you hear me? Can you hear me?
Yeah, we can hear you, but you're kind of low.
Okay, let me try and put more sound. Is it better like this?
A little.
Okay. I'll try again. Yeah, like that? Better?
Yeah, that's better.
Okay, thanks. Look, no, I think my only comment was, do you guys remember this, let's say this test? I think it was made in the 19th century, where people actually tried to sort of to test the Coriolis effect by shooting cannonballs straight up in the air, and often actually so they would point a cannon towards the sky, really, I mean, and just put it as straight as possible. I mean, so measure it really by the millimeter, so it would be really straight, shoot really vertically. And apparently, if I remember correctly, oftentimes the cannonball would actually fall straight into even in the cannon's mouth, so displaying, or in some cases displaying a slight, falling slightly beside the cannon, but really not far from it. I think if I remember, they used to choose a day where there was no wind. So I don't know if you guys remember this or.
Yep.
Yeah, I recall it. Yes.
I mean, has this been done recently, or has this been done again, or is it?
Well,
just something
somebody did something similar with 50 cal. I know that. I watched that video. It was a while ago though.
With what?
They shot a 50 cal straight up, right? And they counted. I can't remember how long it took to come back down. It was pretty substantial. Was it around 90 seconds or so?
Okay.
Something like that. Yeah.
And the rounds landed. They took cover. Put it to you that way.
Yeah, I saw it. They shot it straight up in the air, and then the guy ran, and they all hid under a table, and they were waiting for the thump, and they always heard the thump near the area.
Okay, because I mean, to me, this in the Modus tollens would be this kind of sort of quote unquote experience has less variables than the flight. I mean, the flight obviously is a very good example, but this one is, I mean, in theory, it has less variables.
Nah, the flight's too easy, man.
Okay.
Flights they're pretty similar, but I like the flight ones because everyone can relate to that.
Okay.
But you are correct.
Plus, even if I agree, that's a good example. But with the flight, I think the hang time in an airplane flight would make it more substantial than just the cannonball. You know what I mean?
Yeah.
So
I think
that's why we should definitely see that with airplane flights. We should see that deviation, and we don't ever.
Yeah.
That's the reason why.
I think they always argue that powered flight sort of excuse, but we all know it's an excuse.
No, it's not an excuse. Right. We already went over it. That's why we haven't defined. I defined the Coriolis effect as affecting planes. Why? Because they're not tethered to the Earth. They don't have an argument. I don't know where they got that from. They're just making it up because they haven't defined the Coriolis effect. They wouldn't know the Coriolis effect if it landed on their face, spun around, and whistled Dixie. But hey, appreciate it. Mobius. Go ahead.
Before we go on to that next guy, sorry, just to summarize Moose Tone's point though, because it's in the wash of things, I don't want people thinking that's not valid. So it is the cannonball and the 50 cal, or anything that leaves the spinning reference frame should and would have Coriolis deviation from your point on the ground observing it. Now, that's because the Earth should be turning underneath anything that leaves it. Now, the reason this argument with the 50 cal or the cannonball's been shot down a little bit is because the planes have got considerably greater hang time. Chocolate summed it up beautifully. So the longer it's in the air, the more time the ground beneath it's got to turn underneath it. And what is going to have that applicable? Well, anything that's not attached to the ground. So yeah, 90 seconds is great for a bullet, or a cannonball might be 30 seconds. But a plane several hours in the air, the effect's going to be compounded. Therefore, it's going to be a lot more noticeable.
Yeah, actually, sorry. I think that this test was made because simply planes didn't exist at the time. Yeah.
Fair enough.
Okay. Well,
But-
thanks, guys.
Yeah, thank you.
Chocolate's points even better with the plane as well, because with that nonsense they had in terms of tangential speed, obviously that gives them a lot more leeway for excuse with just firing a bullet. They can try and mitigate that any movement with wind speed is their supposed rotation, because it's the bullet's not just traveling up. Remember, it's traveling 1,000 miles to the side as well. So when you've got the argument with airplanes, especially as airplanes don't go in one linear motion throughout any flight as well, it's a lot harder to apply that cacamamie stuff to the flight of the airplane than it is to try and rule it out for the flight of a bullet or a projectile.
Yep. Next, Mobius. Hello, radio chick.
Yeah, hey guys. I'm at work. It's probably going to be noisy. I'm just listening.
Can you speak up, please, sir?
Yeah, sorry, I'm at work, so it's probably going to be noisy.
Comments, question, rebuttals to the Coriolis effect argument, sir.
He said he's at work. It's noisy. He's just listening in.
Oh, okay. Thanks. Travis Clark.
Good morning, Vietnam.
Yes, sir.
Hey, loving the show. So yeah, I was wondering could you please restate the Modus tollens argument as it applies to the Coriolis effect?
If P, then Q. Not Q, therefore not P. If the Earth is spinning at 1037 miles per hour at the equator, P, then a non-stop commercial flight from Charlotte, North Carolina to LAX traveling at 500 miles an hour airspeed should take no more than 1.5 hours, Q. The non-stop flight takes 4 hours, that is, not Q, therefore not P. The Earth is not spinning.
No, it is not.
Thank
So
you.
no deviation. So it must deviate. No deviation, no Coriolis.
No, it's not that it's not deviating. It is that speed. It is the time it takes to get there. So nothing. That's why I said this isn't a Coriolis effect argument. This part isn't. This is the Coriolis causes. For the Coriolis effect to exist on the Earth, then the causes must hold true. Follow?
Yes, I do.
And if I clarify the difference.
Sure. Go ahead.
So in the example with the plane, the Coriolis effect would be you stood on the ground watching a plane that's got a straight path seem to take a curved path. That's the apparent deviation that is Coriolis effect. It's you observing the plane seem to deviate. Well, if you're on the plane just traveling in a straight line, the reason the guy on the ground sees the plane seem to deviate is because Earth's turning underneath it. And if Earth's turning underneath it, the flight time's reduced when you're traveling from Charlotte to LA. And you can quantify that with the speed of the Earth and how much it's turning underneath it to give the effect of the deviation. But the causes are the argument, not what is giving you or not giving you Coriolis deviation. Once you've peg down what Coriolis is when in the 5-point exploding glowtard example, I forgot the name of it. At the point that you get to point 3, you go, it's no longer there's no need to argue about Coriolis anymore. And deviation, when you phrase it that way, is specifically tied to you observing something going in a straight path, but seeming to deviate as you watch it. But the plane itself, the reason that effect has happened, the Coriolis deviation that you've observed has happened, is because the ground's turning underneath the plane, and you're standing on the ground that's turning under the plane. So it seems to curve because you're turning underneath the plane. So the turning under the plane, the cause of it, is the thing that you, at that stage, point 3, you then focus on completely. So the ground's turning underneath the plane. No, it isn't. The flight time would be reduced. No, it isn't. Drones would deviate. No, it isn't. Hot air balloons would have continents coming towards them when they just fill their balloons up with a bit of hot air. None of those things are happening because the causes that would give you Coriolis effect are Earth turning underneath the plane.
Thank you, sir. So we have Zanuck.
Hey,
Zanuck,
we had to go back to John.
Oh, forgot. Okay, John? You're on the air,
off
sir.
mute.
Can you hear me?
Yes, sir.
I feel like this argument can get confused really easy because of the words inertial and non-inertial. I feel like when they use those words, they're begging the question of movement with an inertial. They're like saying that the Earth or that the atmosphere around the Earth is moving at a constant speed. So that's why, I feel like there's a begging the question fallacy hidden somewhere within the language that they use.
Yeah, we went over that and we absolutely destroyed it step by step. But you're absolutely correct. Like I said in the beginning, it's easy to derail this argument based on people's ignorance. You can throw a multitude of balls at the wall to see if they stick here, right? And just confuse the argument. And in the end, everyone's confused. No one gets it. And it's an abject train wreck. So that's why.
Well,
go ahead.
I also feel like non-inertial is, I feel like they've switched the words around to be intentionally confusing because non-inertial means movement and inertial is no movement. I feel like they've done that intentionally.
No, you just have to get into the weeds with them both, but we don't need to go down there right now. Any other comments, questions, rebuttals?
Yeah, his point is valid though. They deliberately confuse and obfuscate the point to make it sound confusing. It's a really simple concept. If the Earth's turning, it is recordable, it's demonstrable, it's repeatable. They can't demonstrate it, so they have to make it sound like a confusing argument, so that you end up applying the status quo rather than saying, "Hang on a minute, this has been deliberately obfuscated." A simple argument. If the Earth's turning, we should see the effects of it. If we don't see the effects of it, it's not turning.
Yep, I agree.
I'll say something real quick and it should trigger Zanuck. I think I have heard Zanuck say that the Earth does not rotate underneath these objects and these things. So if you want to go to Zanuck, that might trigger him to explain.
Well, we don't need too much trigger in there. I see Zanuck has come in under the BALLBUSTERS protection plan. That's a pretty smart move. Now, better follow the zero tolerance rules. Go ahead.
Okay. As Paul mentioned, yeah, the Earth doesn't rotate under objects that just depart the ground, a balloon or an airplane. When planes are flying east or west, they're flying in the air mass that is rotating with the airplane. The momentum is given to that plane before it takes off.
Stop.
From that runway.
Stop. Please define the Coriolis effect. And I want you to cite the source and I want you to put it into BALLBUSTERS.
I think everybody knows the...
No, everyone doesn't, please.
Coriolis is an apparent deflection of objects moving in a rotating reference frame.
Wrong.
That is the truth, and that is what it is.
The effect of the Coriolis effect from the University of Oregon is an apparent deflection of the path of an object that moves within a rotating coordinate system. The object does not actually deviate from its path, but it appears to do so because the motion of the coordinate system. You are incorrect.
That is exactly what I told you.
That is not what you just said.
Can I clarify? Can I clarify?
No, you can't.
So you keep on confusing the reference frame of the observer from the inertial to non-inertial. If you're looking at an object from the non-inertial reference frame, it appears to deflect. Yes, it always will appear to deflect. From the inertial reference frame, it will not appear to deflect. You keep on going back and forth between the two reference frames, and you're confusing yourself and
That
your
would
audience.
be two different reference frames, Nick.
That's two different reference frames, correct?
Pardon me? You know, a reference frame is an environment for which you view motion.
No, you just mentioned
yes.
two different reference frames, sir.
That's what a reference frame is.
You just mentioned, hold on for a second. How many reference frames did you just mention?
I mentioned two reference frames.
Okay, thank you. So we have one rotating reference frame and one non-rotating reference frame, correct?
Right, right.
What is the rotating reference frame?
The rotating reference frame is accelerating or rotating.
It's the Earth in this scenario, correct?
If the Earth is rotating, then it is. If you're viewing motion from the Earth, then it is the non-Earth reference frame. Yes.
Okay, what is the inertial reference frame?
A frame of reference, an environment of observation of motion that is not rotating or accelerating.
In this scenario, what is the inertial frame of reference?
Someplace out in space.
Oh my God. Okay,
I just want
I'm out.
Science class. You need to pay attention, Quantum, because you've been saying this for 30 years, and you're still confused.
Sorry, can I interrupt? Just 1 second. Listen to your descriptions, Nick, and both of them were observational reference frames.
That's what a reference frame is.
Right, but in this
example, is an environment for which you view motion.
Get about 5 words out with Zanik. So in this example, if we have a fixed observation and two reference frames, one non-inertial spinning reference frame and one inertial reference frame, then that would be the application of Coriolis to a spinning Earth, correct?
The non-inertial reference frame would be the spinning Earth, correct.
The inertial would be?
Someplace in space, not rotating or not accelerating.
Rotating, correct?
Not rotating, not accelerating. That would be the inertial reference frame.
The only way it could be rotating would be if it was attached to the rotating reference frame, correct?
No. The reference frame, again, is an environment for which you view motion. You can have as many reference frames as you'd like.
What is the atmosphere reference frame in this scenario?
The atmosphere on the Earth is in the rotating reference frame.
Wow.
People always mock what they don't understand.
Sir!
Atmosphere, but hold on, I'll look at this. So the atmosphere and the Earth are the same reference frame.
Pardon?
Clarifying your position, you said the atmosphere and Earth are the non-inertial spinning reference frame. Is that correct? I'm just clarifying what you just said.
Yes. They can be in a non-inertial reference frame. Remember, an environment for which you view motion.
Sorry, I wasn't asking you. I was gaining clarity, Zanik. Zanik, don't ask me to hold on. I was clarifying your point to make my point. You've hesitated to clarify your own point. We've got a yes. Now I'm going to make my point. If your claim is that the Earth and the atmosphere are a non-inertial spinning reference frame together as one, then there is no Coriolis deviation on Earth.
Of course
ever.
there is. You actually mistook what I said. I'll say it again. The environment for which you view motion. So if you're viewing motion from the non-inertial reference frame, as in on the Earth or in the atmosphere, then you are in a non-inertial reference frame.
That's incorrect.
So that is not incorrect.
It is incorrect. We just showed you that.
You got to check yourself, Quantum. You got to check yourself.
Right. Betty. Yeah.
Talk challenged. Any chance you can actually let him respond rather than just telling him he's wrong when he hasn't actually qualified him saying you're incorrect? Thanks.
Sure. Go ahead.
I'm not. I'm finished, Nathan.
Okay, so when you throw a ball on a merry-go-round, for example, the ball doesn't leave any reference frames. You are looking at the ball from a non-inertial reference
Oh,
frame.
God.
So it appears to deflect. From an inertial reference frame, it looks like it goes straight. It all depends on what coordinate system you're looking at it from. That's why you have to understand what a reference frame really is before you can actually have this discussion. And that's been confused for 3 years, as far as I'm concerned, on this.
Okay,
on this discussion.
you can talk me through it, Danik. Let's just see how we get on. So let's take the Earth as the non-inertial spinning reference frame in this example. We're going to beg the question, you'll love it. And we've got a football on a playing field.
Okay.
And they're both rotating together as one. The ball and the ground.
Right.
That's so they're both part and parcel of the non-inertial spinning reference frame.
Right.
When the ball's kicked into the air, it would be leaving the non-inertial frame of reference.
No. That's the first mistake you've made.
No. Well, not according to Neil deGrasse Tyson. According to Neil deGrasse Tyson, yeah. Sorry, Zanik. Zanik, excuse me. I'm still talking. According to Neil deGrasse Tyson, can you shut him up, Betty? Because he's just rumpling the shit out of my conclusion. Can you shut him up, please? Thank you.
Yeah.
So, while you might want to disagree with me, Zanik, Neil deGrasse Tyson tweeted out to bazillion people that was very specifically a demonstration of those two separate reference frames. According to Neil deGrasse Tyson and his tweet, calculated by the best mathematical boffins of this world, he stated that upon leaving the non-inertial spinning reference frame of a spinning ball Earth, we observed from the stands what looked like the ball curving. But it didn't actually curve. It was the Earth rotating underneath, according to Neil deGrasse Tyson and his tweet about Coriolis and the two separate reference frames that were experienced by the ball when it left the spinning Earth and entered, according to him, an inertial reference frame. So you're saying, hissing in the face of Neil deGrasse Tyson, that both atmosphere and Earth are as one, spinning together. But that would be in defiance of Neil deGrasse Tyson's explanation that when the ball leaves the spinning reference frame, exactly as described by Coriolis deviation, that we see it seeming to curve. It's not. It's Earth turning underneath, according to Neil deGrasse Tyson, because it left the spinning reference frame exactly as described by Coriolis deviation. So you saying that they travel as one, number one, air can't be bonded. That's air, it's gas. It's not bonded to a spinning Earth. That's your first problem. The second problem is your explanation of Earth being bonded to the air violates how gas works and wouldn't give you Coriolis, as described by Neil deGrasse Tyson. Now, I don't know who you are, Zanik. You're just some muppet on the internet, as far as I'm concerned. But Neil deGrasse Tyson definitely understands what Coriolis effect is, to the degree that he can go and tweet about it whilst watching a football game and telling everybody how it looked like it curved but didn't, Earth turned underneath to cause the goal to happen, and then go around the circuit on very national television telling people how two reference frames caused that ball to seem like it curved because Earth rotated underneath the ball when it went through the atmosphere, Zanik. So your shite about them traveling together is just some nonsense babble assertion from some complete nobody on the internet. You're wrong. Neil deGrasse Tyson asserts that we have got Coriolis effect when the ball leaves the spinning reference frame, because that's what Coriolis effect is. The only problem with Neil deGrasse Tyson's assertion that when the ball leaves, it experiences a apparent deviation, if we're watching it from the stands, is that if Earth's turning underneath the ball to make it seem from the stands like it's curving when it isn't, then the Earth would also turn underneath planes, which also leave the non-inertial claim to be spinning reference frame of Earth. And planes don't experience Earth turning underneath them in the same way as Neil deGrasse Tyson asserted that the Earth turned under the ball, a la Coriolis effect, because that's what it is. Two reference frames, one spinning, that would be Earth, and one not spinning, that would be the air that the ball travelled through, according to Neil deGrasse Tyson. However, if Neil deGrasse Tyson's right, and he seems to understand Coriolis a bit better than you seem to think that you've got to go to outer space to experience something that you can experience on a bloody roundabout, but you're just an idiot on the internet. Neil deGrasse Tyson understands the actual religious rhetoric of a spinning Earth having Coriolis, 2 reference frames, causing balls to seem to deviate because Earth's turning underneath, according to Neil deGrasse Tyson. And if it's turning underneath that ball as it travels through the air, it's also traveling underneath the plane that's flying over the stadium. But the plane doesn't seem to experience any effects in the same way that that ball is claimed to experience those effects. And you seem to be here to obfuscate that point by claiming that they travel together and convoluting what 2 reference frames are necessitated by Coriolis effect. That's all you're doing. Muddying the waters and projecting that we don't understand that you need 2 reference frames, Earth and atmospheres, the 2 reference frames in an Earth-based Coriolis assertion. You're going to tell us that we don't have Coriolis because they travel together. Because you're a scumbag troll.
Yeah.
Here to lie.
Let's wrap this up in one simple statement. His definition of the Coriolis effect is wrong. I'm going to ask him one question. Okay, Betty? I want you to take him off mute because we got to wrap this up. We're going to wrap it up really quick. My question is, does the air, atmosphere, and clouds rotate underneath the Earth in your paradigm, Zanuck? Yes or no?
That depends on which direction the winds are blowing.
It doesn't depend. Does the Earth rotate underneath the atmosphere and clouds?
You can explain for 5 minutes. Can I just have a minute?
I want a yes or a no, please, Betty. This is a yes or a no question. You already said, I'm just clarifying.
No,
you already said that, Betty, please. You have already said, Zanuck, that the Earth and the atmosphere is 1 reference frame. That is, the atmosphere rotates with the Earth. I'm just clarifying. I want to make sure that is your position.
That is your position.
Is it your position, sir?
The air moves with the Earth. It
Okay,
isn't rotating.
Stop him.
Not directly.
Stop
not
him.
directly,
Betty,
but
please. Stop him. That's his position. I will now. My word. Everyone keep that in mind. 1 second, please. Zanuck's position is that the Earth and the atmosphere spin together. He is categorically wrong. From Coriolis effect, Seagar Douglas, Introduction to Ocean Sciences, we already went over this. When set in motion, freely moving objects, including air, that's atmosphere, and water masses, that's clouds and water vapor, move in straight paths while the Earth continues to do what? Rotate independently. Because freely moving objects are not carried with the Earth, it's over for you right here. You do not understand the definition of the Coriolis effect. That's it. You're done. Last comment, Zanuck. I'll give you the last word.
Okay, so I appreciate your understanding of Coriolis, and there are some points that you're correct on, but many you're not. I'd like to just say that Coriolis is an effect, an apparent deflection, when an object travels in a non-inertial reference frame. And if you're going north or south, that will depend whether the Earth rotates.
It doesn't matter. I already went over that definition too. Let's put an end to it. I was just saying that you are incorrect. Per Seagar Douglas, right here in front. Everyone's looking at this right now. I just read it. You said that the air, the atmosphere, rotates with the Earth. This definition says it does not. Conversation's over. The end. Thank you very much.
Just like to point out one thing also. He just misrepresented what the Coriolis effect is with his reference frames. So he got the reference frames the wrong way around. So he said, when an item travels in the non-inertial reference frame. Well, no, the item would travel in the inertial reference frame.
Correct.
He doesn't understand Coriolis effect. So he's come here to tell us we've been confused for however long he said we were confused for, but then it's just simultaneously described the item, as per his words, traveling in the non-inertial frame of reference. And that isn't Coriolis effect. The non-inertial reference frame is the spinning reference frame, not the frame of reference the item travels through. So he doesn't understand Coriolis effect. He doesn't understand which reference frame is which. And he's just projecting his complete ineptitude onto us as per usual.
Yes, sir. Betty, any late arrivals?
Late arrivals.
Yeah, late arrivals inside the BALLBUSTERS voice chat.
Ooh, okay, yeah. I got a guy named Buster too, but I think that he doesn't talk. Well, we can try. Go on mute, off mute. Buster 2.
Thanks, Buster
Yeah.
2.
Invigorating.
Invigorating and very insightful. Okay, we're going to go quick. Final thoughts on the Coriolis effect. We'll put it to bed before we get to the Black Swan. Paula.
I think Paula dropped.
Thanks, Paula.
Maybe it's dinner time for her, right?
Yeah, that's true. That's true. Anthony.
The biggest argument that I get usually is that bullets aren't in the air long enough, drones aren't in the air long enough, everything's not in the air long enough, but the longest thing that is in the air are planes, and we don't see any effects of Coriolis. If Earth was turning, we would see it with planes. We don't see it with planes, the Earth cannot be turning. Gee, that sounds very familiar, that phraseology. Wonder why that might be. Out.
Chocolate.
Yeah, I always enjoy this argument with Zanuck because he's very good at trying to deflect the argument every which way, but except the way it's supposed to be.
Yeah, that's an apparent deflection.
Exactly. So I hope everybody pays attention to what he just did because it was kind of adorable in the way that Zanuck does, right? He made the air and the earth a non-inertial reference frame. I don't think it's because he doesn't understand it. I know he understands it. It's because he has to make both of those the non-inertial reference frame. Right? That's why immediately when we asked him, where did he go? Into space.
Yes.
Right after describing two different reference frames with a merry-go-round. But as soon as we asked about the Earth, oh no, the only inertial reference frame you can see that from is from space. Right? So just wrong in this argument on multiple levels, and then it doesn't fool anybody anymore. We've done this too many times. So it's a wrap for you and this Coriolis nonsense. Earth is not spinning. I'm done.
10th. Thank you, 10th. I know it's a long one, brother. Hang in there, man. Adam, sir.
I think he's back now.
Oh, is he back?
He was out of the chat. 10th? You might not be able to speak.
Denied twice.
Denied twice. Adam, sir.
I think I would echo what Chocolate's just said. That's the reason. Coriolis is fine. Debating it with ballers, and that's the bit I said where Nathan excels. If you listen to him just unpick Zanuck's obfuscation and confusion. That to me is where it always ends up, and why it's very frustrating discussing Coriolis, because you end up just unpicking untruth when it gets to that level, and it was a great example of.
Thank you, sir. Nathan, you want to wrap this Coriolis effect argument up?
Yeah, big thanks to Zanuck, because I'm more than delighted to have had that happen on account of the fact that you get to see the kind of level of doublespeak that you'll be faced with if you were to ever, enter into discussions with someone at a high level of fundy doublespeak when it comes to globe Coriolis. Not all of them are as proficient as Zanuck, I'll be honest, but doesn't mean that Zanuck's going to be able to break down the barrier that is a needed earth turning underneath balls, as asserted by Neil deGrasse Tyson. They'll assert, no. You wouldn't expect to see any deviation in that ball. Earth and atmosphere are traveling as one. So essentially, they go a slight 90-degree tangent off the actual rhetoric to justify why they don't have Coriolis, just as we described right at the beginning of the show.
Thank you, sir. Appreciate it. That's all for the Coriolis effect argument. Unless we missed somebody, I do not see any new arrivals in there. So we're going to move on to Black Swan. There she comes. Now, since we're a little bit long in the tooth today, and I know the audience doesn't mind going for all that long, we may abbreviate some sections. Depends on how I feel about it. Let's just play it by ear. So, the Black Swan. That is the basis of the entire argument of the Black Swan is the horizon. Simply. Let's go over a few definitions of what the horizon is. Remember, we're going to define everything. We're going to use the Socratic method, not semantics. Semantics doesn't get you out of this argument. It indicts you. The principal horizon is the apparent line that separates the earth from sky. From Merriam-Webster, the line where the earth seems to meet the sky. The apparent junction of earth and sky sailing toward the horizon. Horizon, from Oxford Dictionaries, the line at which the earth's surface and the sky appear to meet. Looks like they're all of one accord. Why wouldn't they? Just simple definition. U.S. Department of Defense horizon in general, the apparent or visible junction of the earth and sky, as seen from any specific position. Also called the apparent, visible, or local horizon. Well, what's the local horizon? From National Geographic. The local horizon, also called the geometrical horizon, is the visible boundary between the earth and sky. Pretty easy. Why is it apparent? That is, not actually. Well, number one is well duh, because does the sky and the ground or sea ever actually meet? No. That's one reason why it's apparent. Number two, because of the observer's height. When you change your observer's height, you change where the geometric horizon is. Now, what can obstruct or obfuscate or obscure the geometric horizon? Well, weather, atmospheric effects, waves, tides, etc. The important point here is the horizon can never be more than 1.225 times the square root of the observer's height in feet. This statement right here, can never be more than, is critically important to state in the argument. Like I said, it can be closer than 1.225 times the square root of the observer's height in feet due to those conditions, but it can never be more than, like I'm saying here. However, on the ball-tarred ball, the geometric horizon can be no more than what its geometric constraints allow. It's based on the observer's height and the radius. From Andrew Thomas Young, San Diego State University, Astronomy Department, subject matter expert. If h is in meters, that makes the distance to the geometric horizon 3.57 kilometers times the square root of the height of the eye in meters, or about 1.23 miles times the square root of the eye height in feet. So, Andrew Thomas Young is just giving you basic geometry. He hasn't cornered the market on geometry. We have another citation. I could put 500 more here. It's just simple geometry, folks. University of Washington, Department of Mathematics. So for all practical purposes, we can estimate the distance to the horizon using 1.22459 times the square root of h. Or perhaps even more simply as just 1.2 times the square root of h, which gives the distance in miles when h is in feet. Very simple. Very easy. You can try to convolute this, but you're going to get busted every time you do. Okay? Ballers. The death of the ball-tard spinning space monkey religion. Again. If the Earth is a sphere with a radius of 3959 miles, then every horizon distance measurement must be no more than 1.225 times the square root of the observer's height in feet. That's the geometric horizon. If you're unsure about this distance, just check all the begging the question curve calculators. Put your eye height in there. It's going to give you the distance to the geometric horizon. Guess what formula it's going to use? I'll give you one guess. So, here's what we have. Complements of BMLSB 69. The original video and this still that's taken from that video is in the info box below. Okay? What we got here, our argument is the horizon distance. That's the only point of our argument. We don't care about these oil platforms other than the fact that they demarcate distance. Like I said many times before, I don't care if you have 35 Chinese supermen on hobbled refracted pink unicorns. I really don't care. This can be doing cartwheels in place. This can be, doing jumping jacks. It really doesn't matter. I don't care. It's red herring fallacy to the argument. I am concerned with this thing back here called the horizon. It is where, what? The earth or sea apparently meet the sky. There it is. That's my argument. Observer's height in this photo is 1 foot. The distance to the horizon is greater than 9.41 miles. How do I know that? Well, the distance to platform habitat is 9.41 miles, and the horizon is behind it. The distance to horizon maximum for a sphere with a radius of 3959 miles is 1.22 miles. 1.22 miles is not in this capture. You see the problem? Even for a 5-foot observer height, the maximum distance to the geometric horizon would be 2.73 miles. I would venture to guess that 2.73 miles is not in this photo. All right, what I did with the black swan photo below, that you'll see here in a few seconds, I gave them 5-foot observer height. Even though, as anyone that can see when watching BMLSB 69's original video, very close, that is, i.e. 1 foot to the water. He even said he was below 1 foot, right? But I gave you 5 feet so we could get past that part of the argument because it doesn't matter anyway. Even if BMLSB was at 35 feet at the shore with his camera almost in the water, which is non sequitur, the maximum distance to the geometric horizon would be 7.24 miles. Even at 35 feet, the geometric horizon would be between these two platforms. Folks, this photo is impossible on a sphere Earth with a radius of 3959 miles. That's it. I don't need multiple photos. I just need one black swan. That's it. The Modus tollens. Now, like I said, along with the Coriolis effect, along with any argument, let's just make this blanket statement. It's more important here. Have to get them, if they have a rebuttal to the argument, for them to restate the argument brought against them. Right? That's not too much to ask. You have to know the argument brought against you to rebut it. If you don't know the argument, then you shouldn't be rebutting it, and you're going to get jacked up yard. You're going to get jacked up yard no matter what. But at least have them restate it, so you can make them look like a bigger fool. So, Modus tollens with the Black Swan. Holy shnikes, this is going to leave a mark. If P, then Q, not Q, therefore not P. If the Earth is a sphere with a radius of 3959 miles, P, then every horizon distance measurement must be no more than 1.225 times the square root of the observer's height in feet, Q. Not Q, because we have a horizon distance greater than 9.41 miles. Therefore, not P. The Earth is not a sphere. The ball-tard spinning space monkey community, please allow me to introduce to you your Black Plague, the Black Swan. There she is. Isn't she a beaut? Comments, questions?
Definitely have. So the analogy is something I don't tend to focus on too much, but today I am, because I want to break it down for anybody who doesn't understand why it's being called a black swan. So with a little bit of harp music, we go back to the start of Flat Earth debate. And with a geometric model, it is asserted that the horizon obscures things in the distance. And it can be qualified how much things are being obscured by the physical horizon with the mathematics of their geometry. Now that is analogous to saying all horizons are geometric. All horizons are our physical sphere edge. All horizons are the curve of the Earth. And we can qualify how much the curve of the Earth is obscuring things. That would be to say all swans are white. All horizons are the curve of the Earth. Now, when you have one black swan, it destroys the assertion that you have all white swans. So if you have one demonstration that breaches the physical geometry, will never be unscrambled if it's scrambled eggs. So this is proven out since the black swan was first born. How can this be qualified? Well, the people who rebut this argument, or have rebutted this argument, or attempted to rebut this argument thus far, have declared very overtly that the horizon we observe is not geometric. Now, the black swan to demonstrate that the horizon's not geometric, and the rebuttal we're receiving is the horizon's not geometric. So, whereas we had all geometric horizons, all white swans, since showing that you can have non-geometric horizons, the horizon will never be geometric again. Their sphere Earth assertion was always assumed by us to play out with its physical geometric horizon. So, we don't have geometric horizons, as they were always argued to be. We'll always observe the curve of the Earth, it's the horizon. Now, the curve of the Earth isn't the horizon, according to their own side. You only need one. Now, that's not to say that there are thousands of black swans. There are. We live on a flat plane. Of course there's more than one. But that doesn't mean that the one, the original black swan, will always be that one black swan that disproved all horizons are geometric, as asserted, to round out the point, by the geometric model. So in conclusion, when the people who rebut us as they do by telling us that we have a non-geometric, refracted, and then with the redundant term of apparent position where the sky meets the ground, they invent a second non-geometric horizon that we observe, the black swan. No longer do we have a physical sphere edge horizon. Game over. Earth curve geometry. It will never unscramble.
Just in.
All right. Still there? Hello?
What did you say?
Hello?
Hello?
Hello? We still good?
Still good.
Are we
Are we
live?
straight on to funding rebuttals? Is Betty there, all righteous?
I'm here.
I'm still here too.
Okay, Righteous, do you take over?
Oh, we're doing this now? Sure.
Okay.
We doing what now?
I guess questions.
No, we're not doing questions right now. We're not done.
Why not?
We got some more of the presentation to go.
Well, I mean, everybody knows the Black Swan by now.
No. Now, we'll abbreviate a little bit, but we're going to keep going.
How is this abbreviated when it takes the same amount of time as everything
I'll
else?
make it a little quicker. We need to hammer this some more.
I think that Swan is going to get battered by
We'll do it
all
real
this
quick.
attention.
We'll do it real quick. Hang in there, guys. Okay, let's
Okay.
move it on. The furthest, the geomet. This is the actual argument, right? I'm going to give it to you again. It's the second time that I've done this. I might do it one more time, and then I'm going to delete it. The furthest the geometric horizon can be on the fairy tale sphere with a radius of 3959 miles is 1.225 times the square root of the observer's height in feet. That's the argument. The farthest the geometric horizon can be. Potential debunks. BMLSB isn't 1 foot. Well, we debunked that on the number 1 Globe Killer Collector's Edition. Number 1 and number 2 points were debunked on those two on the Globe Killer. There is land, that is islands behind the platforms. I took that out to the woodshed and beat it senseless. Number 3, we don't never see the geometric horizon. That's the big one now. Of course, I've had this on here for a few weeks. All you need to say to that is welcome to the flat earth. That's it. Number 4, white swans. We'll get to those. Number 5, Q is a straw man. We don't believe that. Well, then you say welcome to the flat earth because Q is their geometric horizon. Every horizon distance measurement must be no more than 1.225 times the square root of the observer's height in feet. That's based on their Earth's geometry, the fairy tale Earth's geometry. So if you think that is a straw man, then your Earth is a straw man. Simple. Welcome to flat Earth. Refraction, of course, that's all they say. Refraction, they don't know what it is. We already demonstrated that a number of times. They continue to embarrass themselves on the circuit. They just say refraction. Well, what type? Are you talking about atmospheric refraction? Magnifying glass refraction? Prism refraction? Or is it just refraction? Or do you put bottles, plastic bottles, in friggin' bowls of water? That refraction? That's not the same refraction we're talking about here. Right? And we can end it quick. So the geometric horizon, my argument, is refracted? Really? Welcome to flat Earth. You just destroyed your geometric Earth. Quickly, BMLSB photo. This is December, a couple months after the Black Swan. On closer inspection. Now, I can't give you a precise measurement of this horizon, but I'll tell you what. It's not 1.22 miles away from where he's standing. This is a Black Swan. Just deal with it. I don't care what these frigging oil platforms are doing. I'm looking at the horizon. And it can be no more than 1.22 times the square root of the observer's height in feet. Gotcha. You guys are so dead. This is also a Black Swan. Why? Because the horizon is really close to Platform Hill House at 6.2 miles away. If he's standing at 6 foot, I'll give him 6 foot. I'll give him standing up in this photo, because I think he was anyway. I'll give it to him. That horizon should be 3.5 miles away or 3.8. Everyone can see the horizon is clearly near or right on Platform Hill House. This is 6 miles away. Guess what? This is Black Swan. Your fairy tale Earth is dead. Simple. Atmospheric refraction, we don't need to go through that again. We can skip that part for today. Terrestrial refraction is based on 7.6 R. R for radius. Where'd you get the radius from? I'm going to show you where you got that from down below. We don't need to go over this. We're good to go. This is actual looming because their argument is looming. They don't even know what it is. Andrew Thomas Young don't know what it is. They don't know what it is. This is actual looming. All right. Mick West, he shows you that this isn't a mirage. Obviously, it's not. It's not inverted. There's no mirage here. The real horizon's right here, as you can see up here using off-center vision, right? You have a false horizon. He said it was because of a fog bank. Yeah, right, Mick. Yeah, we kind of went and see the boat, right? The sky is being inferior miraged underneath the boat, giving the illusion that the boat is floating above a false horizon. That's not Thomas Young's definition. That's mine. Here's another one. This is color corrected over on the right. Matches my definition. These are the raptured boats. This is looming, folks. The sky is apparently, it's over for them. Sky is inferior mirage underneath these boats, giving the impression or optical illusion that they're floating above a false horizon. You can tell that this is a false horizon right here because it's fragmented. You can see the collage on the ocean of the clouds that's reflecting underneath. It's inferior mirage. This is over. Andrew Thomas Young's definition of looming is a joke, even within their Thomas Young's definition, even within what their paradigm that they follow, they're still wrong. Why? Because Andrew Thomas Young says looming is the appearance above the horizon of a distant object that would normally be hidden below it. Right? That's incorrect. And it's in reference to the horizon, not the horizon above the horizon. So they're dead. My definition is correct, and it exampled and demonstrated in the photos I've just shown. That definition is looming is nothing more than an optical illusion produced by the sky being inferior mirage underneath an object, giving the appearance of said objects floating above a false horizon. That's exactly what's going on here. They're dead. Oh, brother. This is important. Let's stop here for a couple minutes. Horizons, National Geographic. If it isn't National Geographic cited here, I will let you know. They give 5 horizons. Let's see if there's any monkey business going on here. Number 1, the local horizon, also called the geometrical horizon, is the visible boundary between the earth and sky. So that's the geometric horizon. The geographic horizon is the apparent boundary between the earth and sky. Well, the geographic horizon, that's the definition of geometrical horizon. Because the geometrical horizon is apparent. It's the apparent boundary between the earth and sky. So the geographic horizon is the visible boundary between the earth and sky. It's apparent. You can see it. So this is the geometric horizon. Number 3, the sea level horizon is the geographic horizon at sea level. Alrighty then. Well, thank you. Well, since the sea level horizon is the geographic horizon and the geographic horizon is the geometrical horizon, then the sea level horizon is the geometrical horizon. Follow? Probably not. From National Geographic, the astronomical horizon is the imaginary horizon. Whoa, imaginary. I'm sorry. We work at the really is level here. Let's get another definition from Encyclopedia Britannica. Mike, discipline, please. From Encyclopedia Britannica, horizon. In astronomy, the boundary where the sky seems to meet the ground or sea. Okay, well, that's the geometrical horizon. We just defined it above. And lastly, the true horizon is the imaginary plane that passes through. No. You see, National Geographic, we work at the really is level here, not the imagination. Typical arguments that we get. This is the real argument that we have. So the globe horizon, anywhere you want it to be. So we got the astronomical horizon, the apparent horizon, the artificial horizon, the horizon to be named later, and the geometrical horizon. This is joke. But this is their argument, essentially. Or this one is. They've been on the two horizon thing. Well, let's take a look at this. The local horizon, also called the geometrical horizon, is the visible boundary between the earth and sky. So they have their geometrical horizon. Is this the visible boundary between the earth and sky down here? See this down here? Or is this the visible boundary between the earth and sky? And by the way, the geometric horizon is apparent. So you're just conjuring this apparent, and it's redundant. This is just silly games. Ray tracing, I will close out with Al Biruni. Bubby! Because this is where the fairy tale sphere got their radius from. Not from Eratosthenes, from Al Biruni. How'd he get it? Let's take a look. Biruni, 973 to 1048 AD, developed a new method using trigonometric calculations to compute Earth's radius and circumference based on the angle between the horizontal line and true horizon, imaginary horizon, from a mountaintop with a known height. He calculated the height of the mountain by going to 2 points at sea level with a known distance apart and then measuring the angle between the plane and the top of the mountain for both points. Biruni's estimate of 6,339.9 kilometers for the Earth's radius had an error of 0.0026 and was 16.8 kilometers less than the current value of 6,356.7 kilometers. The idea came to him when he was on top of a tall mountain near Nandana in India. He measured the dip angle using an astrolabe, and he applied to the law of sines formula. He also made use of algebra in his calculation. Okay, let's take a look at this. You got the view? Not that complicated, folks. A, highest point of the mountain. A. B, lowest point of the mountain. B. H, height of the mountain. H. Here comes the problem. C, lowest point of true horizon visible from point A. This angle right here. What is this right here? Is this the apparent horizon that we have been told for the past 2-3 months that we're looking at? I got a question. If this is a refracted apparent horizon, how in the world did he compute a geometric radius from it? Turn out the lights, party's over. They say that all good things must end. Call it a night. This is over, folks. It's over. Crash and burn like the $6 million man. Questions, comments?
Yeah, I want to do a little bit of a ritual. I want to, how can I phrase this? The white off a swan. So, originally in the first presentation, you say things, something like white swans are irrelevant to my argument. And then you show someone what a white swan is. Now, that's actually not a white swan. It's actually a black swan. But yet there's a lot of colorblind fundies that still think that's a white swan. And I think with just a little bit of exposure, in other words, show the frame that they use, and rather than shying away from it and saying, oh, well, no, we originally thought this was a white swan, it's not, it's black, because the horizon is definitely not at 3 miles. It's clearly closer to 6. That's hard to qualify when you see that single frame, right, zoomed in, cropped. But I'm certain that BMLS B69 will have zoomed out, and there'll be a qualifying point that can demarcate where a mile would be, or where 3 miles would be, if you follow my drift. My point being that that's quite a useful image, because it's got what they would and have and are currently claiming is a physical geometric sphere edge for a horizon blocking the oil platform Hill House, I believe, behind. Well, if and it is, I know already, but because it's a black swan, it highlights where they would ordinarily utilize a physical geometric horizon and are currently. But in reality, they've got to actually, with that image, which has now subsequently been used to justify a physical geometric sphere edge for a horizon, explain why they can't draw a tangent to that physical geometric sphere edge horizon, because it isn't. It's a black swan. So I'd quite like, if you're up for it, maybe after one of the debates in the after show, maybe even live on one of them, actually wash off that white from that black swan.
Are you talking about this photo right here?
I'm not. I assume so. Yes, that photo.
Yeah, because that's the main one that they've been using, and I came out of the gate with this photo. So, do you guys watch my presentations? Obviously not. That's good. Just close your eyes, put your fingers in your ears, and say la 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 over and over again. That'll help. I love it.
Oh, Ballbusters. Who's got some remarks on Black Swan today? I'm sure you've got something to say. Start in reverse order. Maybe go to Adam first. Is he at the bottom of the list?
Yes. Adam, sir, you still with us? Thanks,
Maybe
Adam.
Betty? Are you there?
I think Adam is not here. Yeah, I'm here. Yeah, the black swan. You keep repeating it, but it's so simple, right? If you see these platforms at a distance that it doesn't, with the whole mathematicians that they do with this radius and stuff, if you shouldn't be able to see those, right? And we see them, and then we see the horizon after the platforms. So that means that we can see further. It's simple. You don't even need any how do you say, modus tollens for that. I think it's simple to begin with. I don't understand why people can't relate to just vision. Why do we need to make it more difficult for them? You can just see the horizon behind platforms. It's even further than we thought that we could see. Let's stop this nonsense and say, pack it in, and let's worry about something else that's going to happen soon. With all these lockdowns and all the other things that are going on now, that's my point.
Now they don't understand
yeah.
the argument. That's the problem. That's why we keep going over and over and over. I'm telling you, just yesterday, I challenged the individual to give me the argument. They couldn't do it. So they don't know the argument. I'm telling you.
Oh, and I got a comment from the chat that they don't like the singing that we do. Maybe not all of them, at least.
I apologize, but get stuff.
It's an expression of joy. It's an expression of joy. Turn out the lights. The party's over. Well, the party is their globe party. They've all been dancing under this globe. This, like, what do they call it? A disco ball that's globe shaped, not realizing that they're not living on that model. Well, turn out the lights. The party's over. It's not a globe. Sorry, if you don't like the song, it's our expression of joy.
Yeah, and singing is part of that, right? Part of the joy. We're on the good side of this argument, aren't we?
All around, Paul. You still driving?
Yeah, Paul's not. Yeah. Yeah. What we got?
And chocolate.
Chocolate.
Hi.
What's the what is this? Like Jack Nicholson?
Did you cover your arm?
I was eating chips.
Jack Nicholson, right?
Hey, wait a minute. Did he cough in his arm
my God.
because it's going to be
Oh my
infection?
God.
Oh my God, he knows exactly what I'm talking about too, boy.
Yeah. I mean, I don't know what do we say at this point besides just rest in peace to the radius of the ball Earth. I mean, they've relinquished their geometry, which depends on their geometric model. But like how Nathan put it before, and was like, yeah, it's based on your model, right? You guys like the model you always claim that you have. You're always asking us for that we don't claim we have, but you have. This is based on that. Your geometry is based on your model, quote unquote. And now you're claiming that you don't have it. You don't see it. My question is, why even call it a horizon? Because it doesn't exist. Every definition of horizon, except for the couple that call it imaginary, which is weird, because we like really is level over here. Why would you describe something that you're supposed to see as something you don't expect to see? What kind of sense does that make? Because every description of the horizon is an apparent position where the sky meets the ground. Apparent meaning like you see it. That's the whole point of the word apparent. You see it. And then you call the horizon apparent horizon because we see it. So I mean, it's nonsensical because you're saying that you don't see the geometric horizon. So I mean, I don't know what else to say after that.
Yeah, when the definition of the
Right.
geometric horizon is the visible boundary between the Earth and the sky, it's the same thing that we dealt with the Coriolis effect. Because when when we got him down to the definition of it, he was fundamentally wrong. So everything that he says after that is fundamentally wrong or fallacious. That's simple. That's why you catch him at the foundation. So you're not chasing your tail for the next hour or 2 hours, chasing their fairy tale arguments. You cut them off right at the legs, right at the beginning. Define the horizon. And then start. Let's see where you get to. All right, just trying to help you out. Trying to help save time.
Right with the fundies then. Got anything else, Chocolate?
No, I'm done.
We got some super chats.
Go ahead.
Yeah, it's Xiaoyan Cat. He said, "I like the singing," and then we got a another super. And he said, "Same here, more singing."
Turn out the lights. Party's over.
Party's over. Ooh, you didn't say that you were going to increase the speed. Yeah, those were the super chats.
Thanks, guys. Appreciate it, Chow. Appreciate that. Okay, you can go down. This is real.
And
Like
Sam.
go ahead.
Xiaoyan Cat and Sam.
Thank you, Sam. Thanks, Chow. So, like I was just saying, this is kind of problematic. If you're just watching this and I'm looking at the people inside, there's not too many Globers inside here defending their fairy tale religion. Just saying. You got a big problem here. You don't realize the gravity of the situation because your globe religion's dead. D-E-D, dead. Every direction you try to get out of it in this argument, there is a flamethrower. And you're going to be feeling, this isn't going away. It's not going away. And we ain't just going to let you walk out of here. Ah! Go ahead, Betty.
Do I need to do something?
Yeah, go down the list. Comments.
Oh, okay. Who do you want me to go to?
Debunk.
Maybe 50?
Let's have one
Go
person
you?
do it. Righteous, are you going to take over from Betty, please?
Yeah, there's only like 1 or 2 persons in here. I think I can handle it.
Okay, go ahead, Righteous. You have the con.
All right, let's see if Unorthodox wants to chat. He's busy in text, so he's got to be here. Oh,
What's up? Kind of in the middle of something.
what about that Alberuni argument? Is this new just to me, or because nobody commented on it?
No, this has been around for a long time. They didn't get the radius from Eratosthenes. They have no primary source document, and their secondary source documentation is belly-laughingly weak, right? The actual radius came from Alberuni.
Wow. So Unorthodox, what do you think about that?
About Alberuni and his methods? I think it's great. I think he's a smart guy.
Even though,
I mean, it's a logical deduction. Where's the problem with the logic?
Where's the problem? You want me to repeat it? If he was taking the angle from an apparent, i.e. refracted horizon, how can you get a geometric radius from that? Over.
Well, it wouldn't be perfect. It would be within an error margin, and you would do it in multiple days under different conditions.
Okay, let's take a look at the Black Swan.
We confirmed his method.
Let's take a look at the Black Swan. Hold on one second.
They had the same result.
Hold on one second. Let's take a look at the Black Swan. Let me get over there. One second, please.
I mean, you got to admit, it is a little odd that his calculation perfectly matches up with
your begging the question fallacy story. Yeah, that's really coincidental. Okay. So in this photograph right here, if Alberuni was right here, and he calculated this horizon right here, and he would estimate that let's make it conservative, that the horizon is 9.41 miles, at least. We could say 10 miles. It's actually much further than that, but we'll just use 10 miles. Alberuni, the radius that he would calculate it of the Earth, you know what it would be?
about 4,000 miles.
264,000 miles.
That's the distance to the moon.
Turn out the lights. Party's over. Thank you.
So how do you explain Alberuni's method matching Eratosthenes? How do you explain the two numbers matching?
Yeah, hold on. It doesn't. Maybe he needs me to tell him off. Did you not just listen to a word that was just spoken to you? It doesn't match a globe model. You don't have a geometric horizon. Sorry, did you not just listen to what was? I'm start getting annoyed with it.
I can show you the calculation right now.
What was your reply about the moon and the distance to it? Did you say that's half the distance to the moon?
That's the distance to the moon, 260,000 miles. What he just stated. I think he's getting the math mixed up.
Hold on. So, based on Alberuni's method, that's how far the horizon in the Black Swan is. You realise that?
Based on, are you talking about taking the Black Swan image and using Alberuni's method on it?
Yeah.
What, like I just specifically said? Yes, if you'd have listened the first second and third time, rather than doing what you're doing now, which is talking while I'm talking, you might have heard that your declaration that Al-Biruni's method gives you something wildly in excess of what you think correlates with your geometric assumption, well, then it wouldn't be a very good method now, would it?
I wasn't speaking, so I don't know what you're talking about there in terms of interruption. But so who measured the angle? I'd like to see your calculation because I don't
Oh
think
my
it's
goodness
correct.
gracious, boy. It's just never mind. Let's continue.
It's too dumb to understand what's happened. That's what's happening here. It doesn't really appreciate what's happened. He's told us that's absurd. That's a massive size. That's using Al-Biruni's method. But Al-Biruni's method's good. My God, how slow are you?
I think you messed up the calculation. I'd like to see it.
Really? How? Really? Really? You really? You know who else thought that? Mr. Sensible. He thought it might make a difference of about a mile. Oh, how wrong he was, though, when you actually use that method to work out how far the geometric horizon would be. Suddenly gets described by the people who do understand this argument as not being geometric anymore. We haven't got white swans, geometric horizons, refracted suddenly. That's because it doesn't match the Al-Biruni method, you bonehead. Not because it's really good, because it gives you, what was it you put it as? Half the distance to the moon for the horizon. Yeah, that seems wildly inaccurate given that you think it's 39.59. Yeah? Hello? Is the penny dropped yet? Maybe another stony silence.
Let's just go back.
I think your calculation's messed up.
Let's just go back to. Let's just go back. Hold on. Before we get to the calculations.
Hold on. He thinks it's Al-Biruni's. The one that you think's really good. That's the one being used.
Al-Biruni used the black swan image to do a calculation.
I mean, how many more times? The calculation's the one that you're defending. It's Al-Biruni's. You think that's messed up, do you? Yeah, we'd agree. Welcome to Flat Earth. That's where you got your radius, you bonehead. Has the penny still not dropped? I don't mind doing this 6 more times. It's fun for the audience. How stupid you are.
Nathan, I think you're mistaken about history. Al-Biruni did not... He's not alive today, so he couldn't calculate your photo using the black swan photo. So he didn't do it. You took his method.
We can.
Hold on, I'm not
but we can.
I'm not speaking. Hold on, let me finish.
Yeah, but we can use these calculations. We can.
And then you applied. You tried to take his method and come up with a number, and you failed miserably because that is woefully. That is like 5 to 10 orders of magnitude off from what you'd expect. Show me the calculation.
Yeah.
You'd expect based on a model.
Yes, right. Unorthodox. It's orders of magnitude wrong. If we've got a geometric sphere Earth beneath our feet of 39.59 and we utilize Al-Biruni's method based on horizon dip measurements, then it would be orders of magnitude wrong. That's right. Welcome to Flat Earth.
No, your calculation is incorrect.
No, it's not incorrect. And let's get hold on a second. Before we get to the calculations, let's just go back to the concept. His concept was to take a refracted, because you guys are saying that what we see is an apparent or refracted horizon, correct?
Yes, just basic physics / optics.
No, it's not physics, and it's not optics.
Optics
You said
is a branch of physics.
So no, it's not.
It is.
No. What's the observed phenomena? Let's go here. I love this.
It's a branch of science, quantum research.
Science. Yeah, science. We're going to use the scientific method with this. Go ahead. Observe natural phenomena, please. That's what I thought.
See an image moving around.
That's what. Oh, you're going to go for this? You're going to go for this?
How about this? Observe phenomena. The
Horizon.
Moving from day to day.
The horizon moving from day to day. That's the dependent variable. What's the independent variable? What you control. Or
what you can measure.
What you vary and manipulate is the independent variable.
Well, we're talking about on an Earth science, so you wouldn't be able to control the temperature on Earth.
Then it's not science. Say goodnight.
Temperatures.
So that point's ended. Okay, now back to the original concept. So he is measuring an apparent refracted horizon and deducing from that apparent refracted horizon the geometric radius. Do you see a problem with that?
You have to forgive me. You broke up.
I'm sorry.
Repeat that quickly.
Am I coming through? How am I coming through, guys?
Coming good.
Coming
You
good?
broke up for me. Would you mind repeating that quickly?
Yeah, I'm going to say it again. So Al Baruni's method was to look at what you guys call the apparent or refracted horizon. So how can he deduce a geometric radius from an apparent or refracted horizon?
Well, you do it over land, and you would do it from multiple locations.
It doesn't matter.
Multiple days, and you would get an average. And we know that from his calculations that it matches Eratosthenes.
It matches Eratosthenes. All of a sudden, it matched Eratosthenes.
It's not going to be perfect by any means.
Right.
But
it's nonsensical at its base. Conceptually, it's non sequitur. Don't you see it?
Because refraction is most abundant over large bodies of water.
That didn't answer my question.
Then you don't have that issue.
I don't care. It's non sequitur. You haven't dealt with the non sequitur yet. I don't care what refraction is. At this point, I don't care. It doesn't matter with my argument right now. You can't use an apparent or refracted horizon to deduce geometric radius. You can't do it.
Like I said, his number matches Eratosthenes.
Oh my God.
So we know it's close. It's not perfect. It's not perfect by any means, but it's close. That's how you know it's true, when you have multiple methods pointing to the same thing.
Hello, you keep going around in circles. The reason it's non sequitur, if it's refracted, it is not geometric. Now you're saying, well, the origin story for where we got the radius value, we all assume in this geometric calculator, doesn't work. But I'll continue to beg the question anyway, even though it's non sequitur to deduce geometry from refracted positions. It's not going to be geometric if it's refracted. It's complete nonsense. You're saying, I don't care, the origin story still matches on the average day when I go and look at it and correlate it with the model that's completely smashed because we don't have a geometric horizon anymore to do geometry with. But I'll still correlate it on the right weather conditions. Well, good for you. You know, if you want to continue trusting in R, you're going to have a job drawing tangent lines in your model anymore if everything's refracted. We keep going over this with you.
I mean, yes, you're true. Light does refract, but there's ways you can account for that. There's certain times, certain temperatures, certain places that you can use in order to reduce that error bar.
Okay.
And there is an error bar. There's always going to be error bar. But when you have two methods converging
I understand.
same
calculation,
you know that is the basis for some truth.
Yeah. Without you launching into what refraction is. It essentially means it's deviated from straight. I just need you to confirm that without talking incessantly afterwards. Can you please confirm that you understand that if it's refracted, it has deviated from straight? You would understand and agree with that? Yes?
Yes.
A tangent straight.
Yes. Right. Like I said, error
Yeah,
bars.
no, that's not your cue to talk, Dumbo. So, geometry requires tangents being drawn to the tip of your curved surface claimed to be physical and geometric and sphere-shaped. That's a straight line, a tangent. And you're telling us about how these things have deviated from straight. Not straight. Not going to be doing geometry then. Do you see the non sequitur deriving something geometric i.e. utilizing tangents, straight lines, but justifying why you can do it on an average day with something that has deviated from straight, the antithesis of what is required for geometry. How long before this penny drops? It's so painful.
Nobody ever claimed it to be perfect. There's an error bar, and it's a margin of error.
Really, in geometry, it's just a straight line. But you morons have got donkey geometry and think that, no, it doesn't have to be straight and perfect. That's what geometry is. So you go away and bastardize geometry. In real geometry, in the real world, it's a straight line. That's what a tangent is. But you carry on pounding the C4 fire, telling us about how it's refracted, deviated from straight. Definitely not going to comply with geometry then, sunshine. You let me know when this penny drops.
Unorthodox.
And after, hey, Chocolate, after you're done, go ahead and let Unorthodox have the last word. We're gonna round it up. So go ahead, Chocolate.
No, go ahead. You can round it.
No, go ahead, Chocolate, and let Unorthodox. I'll allow him the last word.
Unorthodox. You're speaking about a margin of error. So if you have a margin of error, how did you ever get the actual distance of the radius?
There's certain wavelengths of the electromagnetic spectrum that don't refract.
Right, and
i.e.
Al-Biruni calculated that?
No, he didn't use radar.
Right, thank you. So then you can't have an actual distance to your radius, right?
Well, we've since confirmed his calculations and Eratosthenes using radar.
Using
They all
radar.
match. They all match. 3 different methods.
No,
and
see,
they
the
all
whole point of this is that it doesn't match to reality when in the Black Swan, using Al-Biruni's method, the size of the radius would be 264,000 miles.
I don't believe that.
Do you understand how that does? It's not about belief. This is your math, right?
I
The
don't
math
believe
that
you did the
gave
math.
you your radius. You don't believe in math now?
Hold on a
This
second.
is-
Hold on a second, Chocolate. No. It's the using the Pythagorean formula, we can deduce the radius from these measurements. So just as a point of fact, it's Pythagorean formula. Thanks.
Yeah, well, I'll do the calculation after I'm done here, and I would bet you my left testicle it's not 200.
Oh, I'll take that bet. I want that left testicle. Yes.
All right.
Pythagorean formula.
Big boy.
Your nuts on the line, brother.
Yep, your nuts on the line.
We're gonna do it.
Yep. I want to see a Pythagorean formula. Yep, because I got the calculations. I got all of them. Everywhere from 10 miles, 12 miles, 15 miles, 20 miles, 25 miles, and 30 miles. Yes, sir. Got them right here. So thank you very much. I'll add that to my belt. All right. Hey, Betty. Now, I'm going to give you the last word. Unorthodox. That's an unorthodox position for me. I'm going to give you the last word. You got 1 minute, sir. Go.
All I'd like to simply state is we have 3 methods converging on the same value. We have Eratosthenes' method, Al-Biruni's method, and modern-day radar. They all converge on the exact same radius value. That is extremely good evidence that the Earth is in fact a sphere with a radius very close to 3,959 miles.
Thank you. Appreciate it. Let's go ahead and wrap it up with the BALLBUSTERS. Chocolate, you're up, sir.
Yeah, as you can see, it's very easy, it seems now, to get these guys to just concede that their radius is either wrong or different or has a margin of error. Regardless of how they put it, there is no geometric horizon. They've given up the geometry, and therefore there's no radius. And with the radius gone, all types of other things are gone in this heliocentric nonsensical model. So I've said it before, it's a wrap for this ball. So that's it. Over.
Next on the list, QE.
The Adam Meakin, sir. Thanks for that detailed summary, Adam. Appreciate that. And by the way, get stuff. Betty, final thoughts.
Final thoughts?
At least I didn't say just Betty. Final thoughts
Yeah.
on the Black Swan and the Coriolis argument?
Oh, now you defined it for me. Oh, that's too bad. Yeah, it's getting boring for me.
I'm sorry to bore you.
Right? Yeah, it's the same old. Not that you are boring me but how many times do we have to repeat this, right? It's done. We can pack it in. It's done with.
I'm gonna repeat it for as long as I take breath.
Yeah, I understand that, but I don't think that many people will come in and talk about this and have original ideas.
You don't?
Do you?
Really? Well, we'll motivate him. We might have a testicle to put on our belt here in a few.
Oh, that might be a hot nut to crack.
10th, where are you when we need you?
Wow.
All right.
10th is gone, so I take the place from 10th.
Yeah. Too funny. Any admin, Betty?
Not yet.
Okay. Nathan, you're the last man standing.
Am I the last ballbuster?
You are.
All right, fair enough. Just to smash the last 50 comments out of the ballpark in regards to assuming that there's only a margin of error and you could go back on different days. Bear in mind that during this show, whilst taken through one of the methods, the method used to assume the radius value in the first instance, we had a margin error of, well, 39.59 to halfway to the moon. That was the margin of error, just so that people are aware of how badly he was smashed when he made that declaration late in the game. Anyway, no, the Black Swan, I agree. I mean, if people get bored of an argument that obliterates the heliocentric model, then I don't know what they're going to come to a show about that very subject, because that's what it's all about, right? And for me, yeah, it can get a bit boring because their rebuttals are woeful. And half the time, they're joyful because they're relinquishing their model in their rebuttal. And again, I can't see anything wrong with that. To me, that's always going to be absolutely joyful. And I'm never going to get tired of this argument. There's nothing to get tired about it. They get worse as time goes by. So I don't know. I'm never going to get tired of pummeling the heliocentric model into the incoherent oblivion based on its woeful lack of a physical geometric sphere edge for a horizon. That to me is just something quite beautiful. So I thank you for having me.
That's why we love you, Nathan. That you're relentless in battling these people with these arguments. You're getting so good at that. It's great to listen to.
All right, Betty, we'll go ahead and wrap it up. It was a long one today, but I think it was well worth it. I enjoyed the Coriolis effect argument. Last call
Is this because you're getting pizza tonight, or what? That you're now all of a sudden ending it?
Nah, it's not pizza tonight. We're doing hot dogs.
Oh my God! Is that the American food? Come on.
Hey, we're doing hot dogs. We're doing grilled hot dogs, baked beans, and mac and cheese. Can't get any more American than that unless I throw some apple pie down.
Isn't that sauerkraut needs to be a bit?
Oh God, no.
Yeah, I heard that. I don't understand that, by the way, but yeah.
All right.
Okay.
Any last admin, last shot at it?
Last words from me, I would say, make sure you give your family big hugs and touch your face as much as you like.
Thanks, Nathan. Yeah.
And sneeze in your hands.
Yeah, I'm gonna give them a big hug. They'll try to run away, but I'll snatch them up. All right. Any last admin, Betty?
Let me check for. No last admin.
All right, guys. Thanks to all the participants and all the ball busters and gets. Take this #1 ball killer and give it to everyone you know, man. You know why? Because the ball stops here. And we're not going to let you just walk out of here.